This conference will now be recorded.
Sorry, I think I had to hit record, George. All right, I think we're good now. Okay, so when I found out that the team was so few people, I was in complete shock because what I had always known about TechPoint Foundation was all the great and huge things they were doing. So we are a very small but mighty team, and I was a teacher for 16 years. I taught kindergarten, first grade, sixth grade, fifth grade, and about 5 years ago, I found myself just in the kind of a rut and kind of burnt out from the classroom. And I'm sure some of you guys can relate to that mindset, kind of that feeling where you just kind of get burnt out and tired of what you're doing. And my principal had forwarded on to myself and another staff member an opportunity to apply for this grant. And my first thought was, I know absolutely nothing about robotics. This is not the right fit for me, and kind of wrote it off pretty much immediately. And then after some thought, I just decided, I've got nothing to lose. This is something different that would bring some excitement back to what I'm doing in the classroom. And I think the students would really love it. So I went ahead, another teacher and I did it together. And that was 5 years ago. Ended up building the program up to 10 teams. And then I moved to a different school within the district and was able to start a robotics program there, and just kind of grew and developed, completely shifted my mindset on teaching in the classroom and my mindset towards students. And I truly say robotics changed my life because it really did just that. It completely changed my life. It kind of saved me as an educator. I never dreamed that I would be in the position that I'm in now, but when I saw the position and I knew how passionate I was about robotics, decided to go for it. And that was just back in November. So this is new for me. George is the robot guy. And so he is passing the baton to me now to be the robot woman. So I have big shoes to fill, but I'm excited about the opportunity and excited about meeting all of you and all of the many other coaches that are across the state of Indiana. So in today's training, we have just three main objectives. So we want to increase your confidence. Most of you right now are probably thinking, like, what have I done? Why am I doing this? Much like I was 5 years ago, very panicked and concerned. So our number one goal is going to be to increase your confidence. By the time you're done here in a couple hours, hopefully your mindset will be much more confident and excited about what's ahead. We want you to know that you can do this, that it's not, it won't always be easy, but we can guarantee you that you are absolutely qualified and capable to fill this role, and that we are here to help you. So you are not doing this alone. I'm here for you. George is here for you, the entire TechPoint Foundation team, the REC team, which I'll introduce here in a second. We are here for you throughout the entire process. So you do not need to feel like you're doing this alone. There's always somebody to reach out to get some direction and guidance. So we have a few grant requirements. Those of you that are grant recipients, there are a few of you on the call that are not actual grant recipients, that you are taking over a team for maybe somebody else, or you're coming about this in a different route. So just those people, you can ignore these requirements. But if you are a grant recipient, you have to be teaching first through high school, which that we've already established that in your grant application. So that's done. You need to make sure that your school doesn't already have a VEX robotics team. So that is already marked off. If for some reason you found out that you did have one and you already received the grant, we'll just keep going. We'll just overlook that. And then number three, it says 4 to 8 hours. We're able to put it down to 3 hours. So that's actually better than what it was before. And obviously you're here now for that, so we can check that off. A few more things after today would be that you can put together a robotics team of at least 3 students. So it really doesn't take very many students. It'll probably be the opposite. You'll probably be having to turn students away in your first year. But I always encourage coaches, take it as like a pilot year and find a few students that can be your guinea pigs, that are willing to be your guinea pigs for the first year round. And then also you are committed to going to at least one competition this year. We'll talk later about the competitions, but we want you to commit to doing at least one competition throughout the season. Okay, so number 6, you agree to encourage schools within your district to apply for a robotics startup grant. So if you know that other schools in your district that are not doing robotics, we hope that you will encourage them to also apply for the grant. The grant is still open, and it will be open for a couple more months. So there's no reason to not apply even after the school year starts. So we want to encourage them to also apply. It's much like a sports program. If all the schools in your district are doing it, you're going to develop a stronger program. So we really want to encourage all schools, the elementaries, the middle schools, and the high schools, to apply for the grant. And then we want you to include our logo on our major sponsor logos on team t-shirts, websites, flyers, promotional material, and we will get you all of that data. So all of those logos and files, we'll send those to you so that you'll have those to utilize. And then we want you to commit to leading a team for this school year and next school year. We know that things change and teachers move around, but we want you to try your very best to maintain and sustain the robotics team. And then lastly, we will send you a pre-survey and a post-survey to fill out. They don't take that long to fill out, but in return, we will give you a $50 Amazon gift card for each of those surveys. So $100 total to use for your classroom. So there is a real incentive to getting those surveys filled out for us, and that does help us to plan. All right, your first assignment right here now. We want you to go ahead and follow us on Facebook, Twitter, and Instagram. So go ahead and pull out your phones, go to each of these and make sure that you are following. On Facebook, we have our main page, which is our TechPoint Foundation for Youth page. So go ahead and follow that one. And then also in addition to that, we have our TPY Robots page. So you want to follow that one as well. And Instagram, Twitter, and then also the Coach's Corner on Facebook. So we have an IQ one, here's the VRC one. So we have a VRC one and an IQ one. So you have to, we have to approve you. So either myself or George or somebody else on the team will approve you. And I can see you guys are already getting notifications that you guys are doing your homework, which is awesome. Overachievers. So go ahead and ask to be a member of that group. These are really, really helpful when you have questions that you need answered. You can probably get questions answered faster here than you could from anywhere else. And it's going to help because you're going to have that firsthand experience from coaches that are actually coaching, that have been coaching for a long time, or in your shoes, maybe they're brand new. Before you ask a question, use the search engine. So you'll see like this little spyglass. Use that search engine to kind of search for what your question is, because it's possible that it's already been answered months or years ago even. You might be able to get it answered even quicker by just searching for your topic. So make sure you utilize both of those groups. Okay. Wait just a second, give you a little bit more time. Okay, I know it's early, but we're going to go for a second assignment. So this is an easy one. It's just simple. If you have not received an email from robotgrant@techpointyouth.org, just make sure that it is a safe recipient, or maybe contact your IT to make sure. This is our primary email address that we use to send communication. I'm assuming since you're all on this call, most of you probably already received communication through that email, but you just want to make sure that you are receiving emails from us, because we send a lot of important information through that email address. All right, and next up, I want you to go ahead and go to our website. So techpointyouth.org. If you can pull up that website, there's also a lot of really helpful information here. If you're going to pass the grant information on to somebody else in your district that doesn't have a robotics team, obviously you'd want to send them to this robot grant tab where they can apply, or they can find out if they're qualified. And then also across the top here, we have our STEM programs. If you go down to robotics, you're going to find a lot of helpful resources here, and you're also going to find this presentation. So if you go over here to Robot Resources, and then you scroll down to the bottom, I think that's our SRI page, Robot Resources. There we go. So you'll see IQ Resources. And when you hit the plus sign, you'll see lots of other things. So if you ever forget how to register an additional team or how to organize a team, all of these are here for you. So lots of resources here. It has suggested schedule for you. And then if you keep going down, here is today's presentation. So if you needed to reference this, if you'd like to have it open with you now, here is the presentation for this training. And then there's also a PDF version. And then here in a minute, when we split up to the high school people, this would be your presentation with Randy here in a second. I'll pause there for just a second if there's any questions. Okay, so there's really 3 different organizations that come together. VEX being the first one. So this is going to be all of the parts, all of the equipment. They're the ones who sell all of the equipment that you need for robotics. And then they also put out the robotics curriculum. So anything related to the pieces or the curriculum, you would contact VEX. REC Foundation is the robot game. So they're the ones who release the new game every year. They're the ones who organize all of the different competitions in the state of Indiana and across the world, and registration. So when you, most of you guys already sent me a copy of your registration. So REC is the one who coordinates all of that to be registered and then to sign up for new competitions. And we have 2 REC people representing on the call today. So we have Randy Decker and Drew Jones are both on the call. And here in a second, I'll give you Randy's contact information, so you'll have that. And then we are the ones who manage the grants and the teacher training and the coach support. So if you have questions about anything coaching related or grant related, you would contact us. If you have anything about a competition or registration or the game, then you would contact Randy. And then VEX, they have a support email that you can contact if you have any questions about equipment. Let me give you Randy's information. So Randy Decker is your regional support manager, and there's his email and his phone number. So if you want to write that down or take a picture of it, or if you have this presentation up, you'll just want to note that that he will be your contact for that. Okay, so there's a difference between VEX IQ and VEX VRC. VEX IQ is going to be cheaper, so you've got around the $400 range for a super kit. That's everything you see in that picture, everything you need to build that. And then this is grades 1st grade through 8th grade, and the materials are plastic, so there's plastic pieces that snap together, where the high school and the college age have the metal pieces, and they're more around $1,000. And it covers grades 6 through 12, and it is metal pieces. And you can see there's an overlap in the grade levels. So 6th through 8th grade can choose to do VEX VRC, but we don't have a grant that covers that. So we encourage middle school to participate in the VEX IQ component. So if there's any confusion there, that's the difference. And then later we are going to split up, and Randy is going to take the high school coaches to go into more detail about VRC and about the game. So that way you can have, we can kind of split up and not have to be to take as long. So here's a little bit more to separate the two. The top one being the VEX IQ. This is this year's game. So it's played on a 6x8 field, again, all plastic. This is what a super kit looks like, all of the components and contents. And then this is this year's suggested robot. So you can kind of see the difference between IQ and VRC. Just by a show of hands, how many of you have been to a robotics competition before? Okay, not very many. Okay, that's exciting. If you have not been, it is beyond fun. It'll blow your mind. It's beyond exciting, and we'll talk about that here in a second. But REC puts out a brand new game every single year, so the field stays the same, but it's a new field, which requires a new robot. Kids have to learn how to solve a problem, overcome failure, meet a deadline. So it is extremely exciting to kind of see all that take place. Okay, here is a suggested season calendar, so you can kind of get an idea. One of our most common questions is like, when should I be doing what? And so we really encourage in August, don't put a lot of pressure on yourself, don't rush it. August is stressful as a teacher, so take that time just to get back in the swing of things, get comfortable with your students, build that foundation, so don't rush it. And then in September is when you want to maybe start considering putting your team together. And here a little bit later, we'll talk about assembling a team. And then you want to start getting some volunteers together. This is when you'll get your pre-survey, and then you'll start building the robot. In October, this is when we want to start registering for competitions. So even if you're not necessarily ready for, if you don't feel ready for competition, that's okay. You would still want to go ahead and sign up for at least one, because they do kind of fill up. So you'd want to try to get registered as early as possible. And then November, December, you want to really focus on practicing, getting confident, help the students get confident in what they're doing. And then in January, try to really focus on having your first or even your second competition. And then again in February, so you want to really focus on January and February being your competition months. And then in March is our state competition. So we host the state competition at Lucas Oil, and this year it'll be on March 12th. Our plan is to have it in person. So we would love for you to attend state regardless. So whether your team qualifies for state or not, it is an amazing experience, and you should really encourage maybe pull your kids together. You know, we're going to go and see what it looks like, because maybe that's going to be a goal for you the next year or the year after. So we really encourage you to come regardless. And the World's competition is in Dallas in April. And we don't know exactly how competitions are going to look this year. We're going to have both in person and some remote, and we can talk about that more a little bit later, but there will be some virtual options as well, which will be nice, because obviously different parts of the state and different schools are functioning and doing things a little bit differently as we open back up. So that will be taken into consideration as well. So our agenda this morning is we're going to talk about what is robotics and why it matters, and how to coach a robotics team. And then after that, we'll have a break at that time. If you need to use the restroom before then, don't hesitate to do that. But we will take probably a 5-minute break after coaching a robotics team and before we split into the VRC and IQ. So during that time, we'll do the game reveal and talk about the competitions, and then we will spend a little bit of time going over the robot kit. So that will be our plan. We will most likely split up about 10:30, but if I get through it faster, then it might be before that. Okay, so what is robotics and why does it matter? I'm assuming a lot of you, we're starting to hear more about robotics, and we don't want to just give you the equipment and send you on your way. I know if that would have been me, I don't know that I would have continued. I don't know that I would have maintained and kept going, because it would have been way too overwhelming. We do this training because we want you to understand why robotics matters. And robotics is one of the very best things that we can provide for our students. And I think you'll see that as we continue this presentation. It's not just about scoring points and winning trophies. That's fun and it's exciting. but that is not what it's all about. It's really about the skills that are developed and the skills that the students get that will stay with them for the rest of their lives. And this training is not going to be just about how robotics works. You're going to figure that out along the way. Your students are going to figure that all out along the way. This training is about why it's important and how you can be an effective coach, because we really feel like if we can give you the tools that you need to be a strong coach, these students, they deserve good coaches. And so if we give you the skills that you need, then we feel confident the rest will fall into place. There's tons of STEM opportunities out there. We are familiar with lots of different STEM opportunities, but robotics, it fosters the most important 21st century skills, that collaboration, the creativity, the communication, the problem solving, more than any other STEM activity. So it really, we feel confident that it empowers students with those skills greater than any other STEM opportunity out there. And not to mention, it's a ton of fun. So I think the combination of the two makes it a great experience for students. So I'm just curious, why are you choosing to start a robotics team? If you could put your responses in the chat, or you might be, if maybe you're being forced to start a team. So if you are being forced, don't feel like you have to respond. But I would love to just get some feedback from all of you at this point. Why are you here? Why are you the coach? Why are you the one attending training? So I'd love to get some feedback from some of you. Okay, so the students and parents are asking for it. That's awesome that they want it. It looks cool. Totally get that. It does look very cool. Oh, the last school in the district to have a team. Good for you. That's exciting when you can say that the entire district has a robotics team. I teach robotics at high school and then teaching at middle school. Awesome. STEM club. The parents and the students wanted a robotics team. Awesome. I was thinking about principals pressuring you. I wasn't even thinking about students and parents pressuring you. Give students exposure and spark an interest to possibly pursue a degree. That's awesome. Yep, Project Lead the Way is a great segue into robotics. Yep, you might as well compete if you're already doing it. That's right. I love the skills robotics brings to my students. Problem solving, collaboration. Yes. Awesome. Okay, well, that's exciting. We've got some really exciting potential here. That's exciting. Okay, so I want you guys to kind of think about how students currently view engineers, and maybe even us, because I think the stigma or the stereotype is that we think of engineers like this. We think of them as outcasts, or we think of them as a little crazy, or spending hours and hours entering, lines of code, very isolated and socially awkward. And society has really painted this picture for us and for our students. And so a lot of times when they think of engineers, they don't necessarily have an exciting outlook or accepting outlook. They don't always think that this is the right fit for them or that it's exciting. But when it comes down to it, what do engineers do? There's all types of engineers, and sometimes it's super complicated. We don't understand all of it. Mechanical engineering and electrical engineering and chemical engineering, those are all very complicated roles. But when it comes down to it, all engineers solve problems, right? And so it's really easy to simplify it for students and say, engineers, they solve problems. They make life easier. And when we think about people who have done that for us, here are a few examples. And most people, and especially our students, probably have no idea who these people are. Yet these people have completely changed our lives. Think about Ada Lovelace, who was known as one of the first computer programmers. And Larry, and a lot of us probably don't even know who these people are and until we get a description of them. The founders of Google, think about how often we use Google, how often our students use Google. And I'm sure they have no idea who these people are. Nikola Tesla, best known for contributions to the design of the alternating current electricity supply system. Thanks to him, we turn on a switch and the lights come on. We plug things in and they work. So these are simple things that students have come to disregard or take, they don't necessarily understand the level of them, but these are the people that are responsible for them. And oftentimes the problems that engineers solve, they make our lives better. And so we can encourage students, you can be an engineer, you can solve problems. And so when you think about, they don't recognize these people, they don't know who these people are, but I guarantee you they know who these people are. These are people that are right in front of them, right? They see these people. I have 2 teenagers, and so it's easy to know like who they're talking about and who they're following and who they're looking at. And we're going to look at some people that I'm sure they all know very well, and students idolize and look up to sports stars and YouTubers and movie stars. TPY, who I'm sure you've heard your students talk about, he's a YouTuber and a gamer. He has a net worth of $40 million. And he started, by dropping out of college, his mom flipped out when he dropped out of college, and he started working at a hot dog stand while developing his online content. And now he's worth $40 million. And then Billie Eilish, at the age of 13, was recording original songs with her brother in their 2-bedroom house. They shared it on SoundCloud, and she was discovered, and the rest is history. She's holds all kinds of records for being the youngest to do so many different things. And then you've got LeBron James, whose net worth is $500 million, and he almost didn't finish high school. He debated about not even finishing his senior year because the NBA wanted him right away, but he chose to finish his senior year and went straight into the NBA. And our students want to be like these people because it's who they see. It's who is in front of them. Our students are products of the internet, so they aspire to be who they see on the internet. And they think if that one person got rich from being on YouTube, then they must be able to get rich on YouTube too. And I'm not saying it's impossible, but robotics it opens their eyes to other possibilities. It kind of glamorizes problem solving. And our goal as a foundation is to elevate robotics to the same level of attractiveness as some of these sports stars and YouTubers. And that's one of the reasons why we host the competition at Lucas Oil Stadium, because we want it to be just as big as they see on on the internet. So that's something we want to think about. Now, the types of students that robotics attracts. Let's start by saying we don't recommend that you have a school-wide call out. If you just say who wants to be in robotics, you might get way more kids than what than what you can work with. And so we recommend being a little bit more intentional about it. Now, for me, what I did was I work with the teachers to say, okay, I'm starting a robotics team. If there's anybody you want to refer or anybody you want to recommend, because it just depends on the student. Some students need it more than others. And for elementary, we recommend about 4 to 6 students per team. I found that 4 students per team at the elementary level was the best because they're not the best at sharing. They can still learn how to share with 4 people, but I thought 4 was kind of that sweet spot. I've done 6 students and it works. It's possible, but I do think 4 is a little bit better. And then for the middle school, high school, you can do 6 to 8 students per team. And we'll show you some models here a little bit later on how you can set that up to kind of make it clear roles for all of your students so that they're not sitting around doing nothing, or like most of you are familiar with group work, one student does all the work while the others sit back and watch. So we have some strategies to help you kind of avoid that. But what I would do is I would have an interest form for students to complete. And then once they got that interest form, then I would return to them their requirements. So this would easily weed out some of the ones that were not serious about it. And later I'll have a document that you're welcome to use that had my requirements on it. But I required them to make a video explaining why they wanted to be on the robotics team and why they felt like they would be a good team member. Just a short 2 to 3 minutes. I used Flipgrid, made it super simple, just so I could get a feel for where their heart was as far as like why this was so important to them. And then I also had them get a recommendation form from a teacher. So I also have that linked at the end that you're welcome to copy and use. But I would have them give it to a teacher, have the teacher fill it out, and turn it into me. So what this did was it really narrowed it down. Even though I had an initial interest form, that might go for, I think I had maybe 120 interest forms turned in, which is a lot, but we did have about 600 kids in the building. But then once I said, okay, well, now you have to do this. That narrowed it down tremendously. Still made it difficult to make, make cuts, but it definitely narrowed it down a lot. And then I just pulled a couple of teachers to help me after school one day and just said, let's remove the names and let's just, well, I guess not remove the names. We did have them do videos, but some that were kind of impartial, and just said, let's decide out of these students who we think would be the best fit. And not necessarily like the best fit, but who do we think needs this the most, or who do we think this would be the best for? So, and try to make your teams as diverse as possible. It's amazing. You might think, well, these two students can never work well together. You just never know once you pull them together. And we want, as a foundation, our mission is to bring STEM experiences to underserved students, and to help us move our mission forward. We want to make those teams as diverse as possible. So let's look at some different types of kids. So you've got your kid that absolutely loves schools, that loves school, the overachiever, the one who is always going above and beyond. That type of student is perfect for robotics. But also that kid that hates school. So the kid who he or she is not involved in anything, not really connected to anything, and just hates being there. That is a perfect student for robotics as well. And then a student who has straight A's, that needs enrichment, that needs something extra, that is a perfect candidate for robotics. But also a student that has straight F's. Sometimes they just need something more hands-on. They need something a little more engaging. So it's also a great fit for a student like that. Students who struggle socially. I'm going to tell you a couple stories here in a second. The ones that struggle socially, they get so much out of robotics. It's such a great opportunity for them to come out of their shell, for them to be in a smaller group where they can just really open up. And then also the ones that are too social, it's also a great fit for them as well. It's a great outlet for them to be with their friends, to talk, to connect with other people. So it really reaches both. And then you have the students that hate sports. It gives them somewhere else to connect. It gives them something to identify with. It gives them something outside of the sports realm, but still competitive. And then the ones who love sports, because robotics is very competitive. It's very collaborative, but it's also very competitive. And so it's a great place for students that love sports. Okay, I'm going to tell you a couple stories about some of my students in robotics. So on the left here, this is Isaiah, and he was one I hesitated to put on the robotics team because his grades were low, his behavior wasn't the best. And once I select my robotics students, I have them, we go over a contract together, and I have that to share with you as well. But we go over a contract together, and I go over the expectations on how I expect them to act, how I expect them to represent themselves as a representative of our school and of our robotics program. And one of the requirements is they have to keep their grades up. So I stress to them that and it depends, that's different for everybody. So I can't say like a B average or C average because it's different for everybody. But I work closely with their classroom teacher to make sure that their grades are staying up. And I tell them if your grades are not where they need to be, then you might need to take a break from robotics and put your focus on your academics. And then also their behavior. So if I would work closely with the principal and the assistant principal and their classroom teacher to say if their behavior is not where it needs to be, then we need to talk about taking a break from robotics. And that is the same for any sport. I mean, it's going to be the exact same thing. So we should have the same expectations. And Isaiah was a bit of a troublemaker. He absolutely loved robotics, but he was a bit of a troublemaker. And his classroom teacher would share things with me and it describe him in one way. And then I did not see that at all when he was with his team and when he was practicing after school. And so there was more than one instance where his teacher had to come to me and say, like, he's just not behaviorally just not cutting it. And so we together talked to him and said, listen, you need to get your act together and you need to start making better choices or you will have to take a break from robotics. And that's all it took was that conversation. And we never had to revisit it. He did exactly what he needed to do. Was he perfect? Absolutely not. but he was definitely improved from what she was dealing with before. And it was really robotics that kind of kept him on the straight and narrow, and kept him kind of doing the right thing in the classroom. So I actually also had a student one time that he was a great kid, such a great kid, but he got into an altercation with another student, and the student had pushed him, and then he pushed him back. And so, as you know, like they're both in trouble. And his dad came to me and he said, Chase was like absolutely sobbing over this, and he was like, and I knew like that was normal for him to be upset because he got in trouble. But he was like, it was a whole other level of upset. He was devastated. And I asked him, Chase, why, what is going on? Like, why, I know you're upset and you have every reason to be upset, but why are you so hysterical? And through his tears, he said, Mrs. Inskeep's gonna kick me off the robotics team. And he was just so concerned that he was not gonna be on the robotics team anymore. So we worked through that. And like I said, he was a great kid. It was a moment of weakness. And so we definitely worked through that. But robotics has that power to really keep kids on the straight and narrow. On the right side over here, this is Aiden. Aiden is one of 4 brothers, and he has 2 older brothers that are extremely athletic, naturally gifted in athleticism, involved in every sport. Around this time, his little brother passed away from cancer. And as you can imagine, it was a very, very hard time for them. He joined the robotics team, and it was one of those where he needed it. He absolutely needed it. And so we put him on the team, and his mom years later has come to me and said that he's always looked up to his older brothers that are involved in sports, and he's never fit in with the sports. He's never been the athletic type, even though his 2 older brothers are. And he never really found a place to belong outside of sports. And he never really felt like he belonged with sports because he was never really good at them. And she said robotics was exactly what he needed at exactly the right time. And he was on our team for about 3 years, and really just thrived, just did an amazing, amazing job. And I really believe that really helped him get through such a challenging time in his life. And it's probably helped him with direction for the rest of his life. So that's a couple of examples about students for your teams. When you think about robotics and what it kind of does, I think that the circles around the big circle in the middle, they really are the obvious ones. You can utilize STEM mentors and get volunteers in there that have a STEM background and the teamwork and the programming. For the high school level, more of the electrical and obviously mechanical of construction. But then the outside parts, the communication, the collaboration, the problem solving, the real world, and the critical thinking, those are maybe the less obvious. And you see them develop over time. So they're not something that you see in the first practice. These are things that you see develop over time. And later I'll share a couple more stories about how I saw some of these develop in my own students. And these will apply to any job that they go into. So STEM or non-STEM field, those are skills that are going to make them successful in whatever they choose to do. So I don't know if anyone has ever seen this, but it's taken from the New York Times. There's a New York Times article, how to get a job at Google. And as we know, Google is one of the very top companies in the world, and they attract so many talented people. And because of that, they can afford to look beyond the traditional metrics of things like GPA or test scores. And so these are the kinds of things that they're looking for in their employees. And these are the skills they're looking for over anything else. So when you think about, I'm not going to read these all to you, but when you think about these skills, look at the very last one is expertise. So it's the very last one on their list because they consider it to be the least important. So they're not concerned about how well you know the content or how well you can regurgitate the data. They want to know, what kind of leader are you? And can you process things quickly? Can you work with others? And can you admit when things are wrong and be willing to be flexible? So I share this. I used to share this with my students every single year at the very beginning of the school year, and explain to them how important these skills are, and that as a teacher, my #1 priority was to develop these skills, and that all the other things could come after that. And so it's not all about their test scores. It's not all about their grades, but it's more about how they're developing as human beings. And so I think it's important. And I think robotics checks off every single one of these. So just one more reason why robotics matters. Okay, so this is exciting to kind of show you that in the beginning of this state robotics initiative, so back in 2015-16, which would have been the year that I received my grant and started my team. In the beginning, so Mayor Ballard, former Mayor Ballard, and Randy Decker, who's on the call, they're responsible for these initial teams. So we're so thankful for them and their heart for robotics and their vision to start these initial teams. But as you can see, they're all pretty much centrally located. You just have a couple out here on these islands. And so we started the State Robotics Initiative. And since then, you can see the growth. So it started with just elementary schools, now elementary, middle, and high schools all across the state of Indiana, over 2,000 teams. We're in over 300 districts. We're in 90 of 92 counties. We have more elementary and middle school teams than anyone else in the country. Now, California has more VRC teams, more high school teams, but we did open up the VRC grant last year, and so we're hopeful that we can surpass that. But as of now, California does beat us on high school teams. But you can see what a huge progress and the work that's been done. And so we just want to take this time just to thank you guys because you are part of this initiative. You are helping to contribute to our goal of getting a robotics team in every single school in the state of Indiana. So thank you for starting a team and contributing to this initiative, because you guys are the ones that help us make this happen and make us great. So we want to thank you for that. And then looking at competitions, back in the beginning of the initiative, there were about 12 competitions, and as you can see, it'd be really difficult for anyone to compete. They'd have to travel very far to be able to compete somewhere. And now we have competitions that are more dispersed and more laid out across the entire state to make it more accessible to the teams that are not in central Indiana. So those of you that are outside of central Indiana, there's more opportunity now, and we can continue to add more and more competitions throughout. So be on the lookout for all of those to come through. But at this point, you shouldn't have to travel very far. In some cases, you might have to if there's not a lot of competitions, and just depending on the schools and what they're able to do with COVID. Some are going to be more open to hosting than others. So just be open to the fact that you might have to travel a little bit, but hopefully not too far. Okay, we're going to look at coaching robotics. Move into the coaching side of things now. So you'll want to build the basic bot from the instructions. So I'll show you here the IQ build instructions. So you can see the robot changes each year as far as what they recommend. This does not mean that we want you to build this exact robot and compete with it. This is a starting point. We want you to start with this basic build so that you can kind of get an idea. REC puts this out as a recommended robot to complete the challenge that was put out. And as you can see, the robot changes every year because the challenge changes every year. When you click on the build instructions, and I'll show you VRC here in just a second, it's very much like Lego directions where it's step-by-step. It shows you exactly what to do. And for this reason, you can be 100% hands-off. Your students can do this. You can be there to coach them, to cheer them on, but they can absolutely do this by themselves. And so you can kind of see it does give them step-by-step instructions, and they're used to following instructions like this. At the very top will show them which pieces they need to get out of their kit, and then it'll take them step-by-step through every part. Now the V5 one is the same concepts, just different robots because it's a different challenge and they use metal pieces instead of plastic. So we want you to make sure you modify your robots to not look exactly like the ones in the instructions, and your students are going to struggle through that. Like they're going to probably do great at following these directions. They're going to probably thrive on doing this, and then they're going to be done, and they're going to say, okay, now what? You want them to kind of struggle through where to go from there. You want them to start testing it and seeing how it works, and then making modifications, and then testing it and making modifications. Your job is just to encourage them to think like engineers and solve problems as they come up. If any of you, I know that we had some Project Lead the Way teachers in here, I think, and I was a Project Lead the Way teacher myself. One of the biggest things I took away from Project Lead the Way was, and I don't think they say it like this anymore, I think they've changed their wording, but when I was back 5 years ago when I became a project lead the way teacher, and they used to say, as an instructor, you should be the guide on the side and not the sage on the stage. And that really stuck with me, because I feel like as a teacher, you want to fix things, like you want to make sure they're doing things right. You don't want them to make mistakes, but it's so much the opposite. You really need to let them make those mistakes and just be the guide on the side to ask those questions, to help guide them, to help direct them, and let them figure it out on their own, because that's more impactful for them, and it's more exciting for them to figure it out on their own, to succeed on their own. And I can tell you from experience that you will enjoy coaching so much more if you don't stress over having all the answers, because putting that kind of pressure on yourself, it's not necessary. These students, they're smart, they're capable, they will figure it out, and you just have faith in them that they will. Have them prototype. So maybe you have students that are working on a prototype, so maybe they're just experimenting with the pieces, they're trying different things, they've seen the challenge and they have some ideas. Have them prototype some ideas before they actually put it on the robot. And you have to really try not to start over. I've had this time and time again where students will build an entire robot and it's just not working the way they want it to, and they're like, we're just going to start over. I'm like, no. You do not want them to start over. It's way too stressful to do that. You want to really encourage them, what can you modify? What can you change? Maybe, is the arm too long? Okay, how can you shorten it? Is the robot moving too slow? Okay, how can you adjust that? So try your best to not let them start over, because that'll be too stressful for everybody. And think more about modifications. And practice driving. I can tell you firsthand experience, so many students, they love the building portion. They love when they get it done, but then it's like I'm constantly, great, time to practice, and they underestimate how much practice they really need. It's a brand new thing for them. They have to adjust to it. They have to adjust the feel of the remote, and a lot of them think, well, I can play video games, so I can do this, or I have a remote control car at home, so this is easy. They really need to get comfortable with the driving, and that will make all the difference for them, their confidence level, how they do in competitions. So you really want to make sure that they're practicing consistently. You could even set timers and say, okay, like you're going to build for this long, and then from this time to this time, you're going to practice. And if you have the volunteers, or if you're able to, if you can sit there with them and run a timer for them to practice, that helps a lot too when they have that person. I used to have parents in my practices, and I would tell them, like, don't touch the robot, but you can be there to encourage them to keep, stay on task and keep practicing. So that's something to consider. Okay, I'd love to hear in the chat, if you guys can type in, how will you measure success? So when you're thinking about your robotics team, how will you measure the success of your team or your program? What kinds of things will help you to know that things are going right, going well, and that you're happy with how it's going? So go ahead and put some things in the chat. Make sure everybody's still awake. Yeah, the kids keep showing up, so they're not skipping out of practice. They want to be there. Thanks, Michael. Bree says it's really about how they assess and overcome whatever issues they run into. Absolutely. So when you start seeing them overcoming on their own and not having to have someone mediate that, that's a great sign of success, that they're learning how to work together. Yeah, is everybody contributing? Are they leaving people out? Is everyone hands-on? Absolutely. Yeah, checkpoints. Like, from at this point, you really should be here. And if you're not here, then, are you getting distracted? Absolutely. Yep, setting goals and seeing if they can complete them. Observing their engagement with the material. Justine says, asking the hard questions, thinking about outside of practice, telling their peers about it. Absolutely. When they're talking to other people about it, that it's successful. Bo says, participation, perseverance, successful troubleshooting without bickering. Absolutely. And there will be bickering. I'm not going to sugarcoat it. They're going to fight. They're absolutely going to fight. And for the most part, I ignore it because they always work it out. I have had a few instances where I've had to have team meetings. So I've had to kind of pull them into a separate room. And again, I still let them do all the talking. I'm just there to mediate. I'm just there to ask questions, find out, get to the bottom of what the issues are. And it's really powerful to see them kind of navigate through those and come out stronger as a team. So they're definitely going to bicker. But when you think about working so closely with other students on a common goal and the pressure that they probably feel to be successful, it's definitely going to happen, but it's really how you respond to it. Awesome. Thank you for that participation. Okay, well, let's think about coaching ethics, because you're going to see, let's start with not being worried about trophies. So we're telling you as the director of programs and the CEO of TPY Foundation for Youth that as the people who host the state competition, like, we are not concerned about trophies, and you should not be concerned about trophies. It's fun to get trophies, but that should not be your focus right now. Your focus should be just building and strengthening your team. Also, as I've already said, failing is okay. As long as you're learning from your mistakes, and your students will feed off of your energy and they'll feed off of what you're saying. So as long as you are saying it's okay to fail and you can learn from this, they're gonna pick that up as well. So they're definitely it's gonna trickle down from the leadership. So make sure that you're staying positive with them no matter what. Student run, adult organized. So this is huge. Just like anything else, parents like to get involved, adults like to get involved, and REC is really cracking down on this. And you're going to go to competitions and you're going to see robots and you're going to think to yourself, like, there is no way that student has built that robot. That in some cases it's true. In some cases, the adults built it, and that's unfortunate. And then in some cases, the students truly did build it. So I've been to multiple competitions and I've seen so many different robots. And I've actually had students come running up to me. We just saw over at this team, this adult was fixing this robot. They want to tattle right away, like, because I make it a big deal on my team. Adults do not touch. And I tell them, like, if your parents try to get involved, if your parents try to touch your robot, I train them and coach them to put their hand up and say, no, this is my robot, you cannot touch it. Just like a project at home, parents tend to get involved. We all know, we've all seen those projects. But when they run up to me at a competition and tattle on another team who is a coach or parent is touching the robot, I just encourage them that, and again, how you respond is going to be reflection, and then they're going, that's what they're going to pick up on. And so I respond that we can only control what we are doing. So we're not going to put all of our energy into what others are doing. We're going to leave that to REC to police that, and we're going to focus on what we can control, and that is how we are handling things, how we are representing ourselves, how we are student-centered, and we don't allow adults to touch our robots. So it's just really important that you push that from your level as well. So like I said, no dad mom bots. Keep your parents, and for me, when I had adults that were volunteering, I actually had one adult that was way too hands-on, and I had to talk to him multiple times, and he would say, I'm sorry, I know, I get it. And so I made it very clear, like, if you cannot stay hands-off, then you will not be able to join our practices or be in the pits during the competition. And so that's all you have to say, because they want to be involved, they want to be there. And so usually that's all you have to say, and then they will back off. So just don't be afraid to tell them no. And you don't have to have all the answers. And I think I touched on this already. You will make yourself crazy trying to have all the answers. So release that from yourselves right now and give yourself some grace, and do not expect to know all the answers to all of their questions. I would always say to them, you know what, I don't know the answer to that. And it's good for them to hear you say that. But together, let's figure it out. Let's go back to the game manual, or let's go on the forum and let's ask that question or see if that question has been answered. Let's figure it out together. And so you don't have to have all the answers. And I think it's refreshing for them when they see that you struggle too. All right, stress level. Even after coaching for 5 years, I can still find myself on this stress cycle. So let that encourage you that you're always going to have this level of stress, and some is healthier stress and some is less healthy stress. But I can tell you that I've never, in my 5 years of coaching, have never had a moment of regret. I may have been way up here on the stress level, but I've never had an ounce of regret for coaching robotics. So pre-grant, before, you were smooth sailing, right? Everything was fine. You were getting by. You were clocking in, clocking out. Everything was great. And then you got awarded you chose to apply for the grant, or your principal encouraged you to, and you got awarded the grant. You were probably thinking, okay, I didn't know if I'd actually get this grant. Now here I have it, and I have no idea what I got myself into. Those are normal feelings, so don't panic. And then hopefully, in the midst of professional development, you're starting to think, okay, I've got this. Okay, Jamie says I don't have to have it all figured out, so this is making me feel a lot better. And then the students get involved, and you see how excited they are, and you see their faces lighting up, and you see the conversations that they're having with their peers, and you think, this is so fun. Like, I'm so glad I did this. And then a competition starts creeping up on you, and maybe you're saying your 4-letter words, and you're thinking, how in the world am I going to do this? I don't know what I was thinking. And then you're also thinking that you have no time, that it's time to compete, and there's no way we are qualified to compete. But let me assure you that if your robot can move, then you are doing a competition. So do not hold back from a competition just because you don't feel prepared. As long as that robot is moving, and I'll show you here in a minute some strategies on scoring on our new challenge, but I'm telling you, the best thing you can possibly do is just suck it up and go to that competition with a positive attitude, because your students and you are both going to learn so many things at that competition. I kind of approach it as like a dress rehearsal. Things are going to go wrong, things are going to mess up, but you're going to learn more by going to that competition than you ever would if you just stayed back and just kept practicing. So please make sure that you just bite the bullet and go. And then after that first competition, you're going to be saying, what in the world did I get myself into? Because it is going to be overwhelming for you. I'm not going to sugarcoat it. That first competition is extremely overwhelming, and so you might be overwhelmed at that point. But then by the time you get to your second competition, it's going to be completely different, and you're going to go back to saying, this is fun, I'm so glad I did this, and you're going to be right back where you were. And then you're going to all be robot masters. You're going to be experts and ready to go again next year. So that is kind of our stress cycle. Okay, so where to get help? If you notice, we are at the very bottom. So you don't have to reach out to us because there's likely all of your questions are going to be answered from other people, and you're going to get support from a lot of other people. So you have the REC website, which these are sites that you probably would want to bookmark on your computer to have access to, including our website. The forum on Facebook, that, like I said, is such an amazing resource. So many coaches on there that you can connect with. And then our robot resource page, which was what I pointed out at the very beginning of the presentation, where you can get this presentation, and then you can also get lots of other resources. A STEM mentor or an assistant coach, like, I can't stress enough how important it is to get other adults to help you, and we'll talk about that a little bit later as well. But that is a huge thing. And then neighboring school, either rookie or veteran, those of you that have other schools in your district that have robotics teams. So if you are elementary, maybe in middle school, high school, someone at that level that can come and help out, that would be huge. So utilizing the older students in your robotics program. I always hosted a summer robotics camp, and it was easy to staff it because I always just said, okay, if you've already graduated through my robotics program and you're at the high school now, or even at the middle school, then you're going to come back and work my camp. And you've got a built-in volunteers right there. So as you build your program, you can always have those veterans come back and volunteer. And then team registration, competitions, general questions. Remember, all of those things go to Randy Decker. VEX parts, there's your phone number and your email for VEX. So if you ever have questions about any of the parts, if something's not working properly, or if you have any questions at all about the equipment, then there's the phone number and the email. And then lastly, if you have questions about the grant, the recruitment grant. So if you recruit another team that does not have a robotics team, if you recruit them, we will give you a $150 VEX gift card. So something to consider. If you can recruit another team, then we can give you a gift card to purchase more equipment. And so that is on that website. That's on our website. Under when you guys applied for your grant, you should have also seen where it said recruitment grant. So now you would qualify for that. And we're getting close to our break, you guys. Okay, so the advanced VEX IQ coaches training. So this is, I think I have it pulled up over here. Yeah, so this is a playlist of YouTube videos. These are extremely helpful. We do this for our coaches that are already established, but you guys can also get a lot out of this. We have it broken down into different categories. And I want to point out the one that I would recommend the most at this point of where you're at would be this VEX IQ pitching in game review. So this is 2 coaches that are very established coaches that are reviewing the brand new game. So they're going through like page by page of the game manual, and they are going over every part of that, explaining it, discussing it. And I know it's an hour and a half, but I promise you it's worth it. It'll help you feel way more confident in this year's challenge. So that would be a great one to get started. And then the other ones as you kind of see fit, but that would be the most useful one probably for you at this point. And then also the educator certification. So you can be this is not required, but it's a great kind of next level thing to achieve, to be certified through either V5 or IQ. So it's going to also have all the ins and outs, and it's going to help you to understand everything a lot better, so you can see the different levels. So you have the IQ certification and then your V5. And so this is a great thing for those of you that really enjoy, your badges and your accomplishments. This would be a great thing for you to work on, in your spare time, because we all have so much of that. Okay, so this is a sample schedule. So this is, I want to emphasize sample. This may not work for you, but a 1.5 to 2 hour meeting once a week is ideal. Some do more, some do less, but I'd say that would be the average of what most teams do. And you would have your first meeting. So this is where you would go over like your team structure, the game rules, your scoring, the expectations for your team. And I have a presentation that I'll show you here in a minute that you can copy and use for yourself for this, that I think it really takes up really the whole meeting. That first meeting, I tell them this is going to be a little bit boring, but it's so important for us to know, to all be on the same page and to build that foundation, to have a strong team, and then really kind of approach the game and let them brainstorm, like how would you score points with this game, what would you do? And so we go over all that and then go into building the basic bot. You learn about the parts and how to use them and how to kind of make sure that you're using everything correctly, and then let everyone get a chance to drive the robot. So you want everybody to get that exposure. I used to say you might decide who are your strongest drivers, but every single person is going to drive the robot. So I think it's really important that they all have that experience, especially in a competition, that they get that exposure. They have people that come to watch, and so we stress, like, we may not get equal driving time, because just like in a sport, you recognize that some people are stronger point guards or stronger quarterbacks, so they might get more playing time. It's the same thing in robotics, is what I tell my parents. And I have a parent meeting at the very beginning of the year, and I'll go over that a little bit later, but I stress to them, like, they're not going to get equal driving time, because they're going to decide, they're going to figure out who their stronger drivers are over time, and then those are the ones that are going to drive more. Now, I do require that every single person drives at least one time, because there are people there watching, they want to see them. I want them to get that exposure and that experience, but it's not going to necessarily be equal driving time. And then we talk about the game strategy. We don't necessarily design the robot just yet. Like, we maybe have built the basic robot just to experience the driving of it, but we have not necessarily designed a new robot for the challenge. And then we talk about, then we have a discussion on how we want to design the robot. We start prototyping appendages, so that's the arms, any kind of expansion pieces, We start testing, then we redesign, rebuild, and then keep practicing. So that kind of gives you an idea of the layout. And then, like I just described, the design process, I think everybody is probably familiar with this, but I don't think robotics supports the design process probably more than anything else that you do in your classroom. You know, that whole thought of brainstorming and prototyping, testing it, redesigning it. This is going to be a constant cycle throughout the entire season. So I had referenced some sample coaching structures a little bit earlier. So I want to show you some examples. This is what we recommend, that you get somebody else to help you. So this could be another teacher, this could be an assistant, this could be a parent, this could be an older student. So just think about who that person could be, and it could be that this person is just in charge of logistics as far as collecting permission slips and collecting money, or communicating with parents, or whatever it may be. So maybe it's more of a logistical person, or maybe it's somebody who's more supervising practices so that you can be doing other things. So just think about who that person could be, because if you do this model where it's just you and your team, you might burn yourself out. You probably will burn yourself out. So try really, really hard. I'm thankful, I'm grateful that I've always had an assistant coach up until last year, actually. But I've always had an assistant coach, and it just helps so much to have that person to talk to divide and conquer kind of thing. So try really hard to have that assistant coach. This would be more of a high school model. So you would have adults involved, and then these blue boxes would be different roles for your students. So as I mentioned before, high school teams generally have a bigger team because there's a little bit more for them to do. So you could have different roles and jobs for each of your students that are on the team. And then this would be more of a elementary model of this. So you have your adults, and then you have students that might have might focus on different roles within their team. So I always tell my students, like, they all do everything. They are all responsible for everything, but I might have say, okay, this student is overseeing the design notebook. And so that does not mean that person is the only person that writes in the notebook, but that person is one that makes sure that the notebook is written in. So just kind of defining those roles and giving them some direction is going to really improve your practice time and make them a little bit more effective. And then here's another option. If you have a smaller team, then you might do something a little bit more like this, where you have one student that's focusing on building, one that's focusing on programming. And programming is not required, but we do encourage you to try it. It's not going to hurt to try it, and and we'll talk more about that a little bit later. But it's a great exposure for them. Okay, one of the coaching tips we have would be designing the robot and practicing driving. Design and driving are both equally important, but they're obviously two different things. So they need to be doing both. They need to be designing the robot, but they also need to be practicing driving. And you will find that there'll be several students that they will focus so much on building and designing, and that you're having to remind them, okay, now go practice with it, because they get so, sometimes they get so tunnel vision, and they have a vision for how they want the robot to look, that they get distracted and forget to actually drive the robot. So please make sure that they are doing both equally, driving and designing. Okay, we're almost done. Just a couple more things, and then we can take a little break. But I wanted to show you some of the resources that I have utilized in the past that I think could be very helpful. These are all linked for you that you can copy and use for yourself. I'm not going to open all of them, but I do want to show you the beginning of the year presentation. So this is these Bitmoji presentations have gotten a lot more popular, and you can absolutely copy this and use it for yourself. But I would have, it would make, since that first meeting can be a little dry when you have so much to go over, it makes it a little bit more interesting for students when it's more engaging for them. So you can copy this and use it for yourself. I have not updated it for this year's challenge, so obviously you would have to make some updates, but everything on here links to another page in this presentation or a link outside of it. Like the game manual is right here. The design process is right here. But I go over the expectations, what I expect from them when they're in practice. I go over different job roles, so different things that they could do on the team, and stress to them that we don't know who those people are yet. Like, we're going to figure that out over time. And then I give them a guide for the structure of each meeting and how to do their notebook. So I don't want them to ever say, I don't know what to do. And I actually print this and post it on posters on the wall in my robotics room. So I'm constantly, if they say I don't know what to do or I have nothing to do, I'll point them and say, you need to go through all these questions and you need to figure out what you could be doing right now. We go over upcoming competition. So those, I pick those out at the very beginning. The engineering notebook. So there's the rubric for the notebook is right here. Other links, all kinds of different things. And then a lot of those are then linked to some of these pages that go out more specifically to different YouTube videos and all of that. So that is there and available to you. And then another one that I wanted to show you is the parent presentation that I think is so critical. And I didn't do this when I first started coaching. And once I started it, I noticed, I actually had a parent that came to me and said, hey, could we do like a parent meeting so we can understand robotics better? And it was really a game changer for me. It really shifted my program because I got the buy-in from the parents. So it went from the parents pick up their kid after school, after practice, and not really knowing what their kid really did. Like their kid would tell them, but maybe not to the extent that they would understand it. And so at the start of each season, I started doing a robotics parent meeting. And this was a great time to get all my permission slips signed and turned in, that I didn't have to go chasing after the kids for it. And I would have really great attendance because they really are curious. They want to know what robotics is and what their kid is doing. And so I go over the exact same expectations with them that I went over with the students. So they are all on the same page. They know what I went over with their kids. I give them dates for competition so they can go ahead and put those in their calendar. This is from a couple of years ago, but I show them the challenge. So I show them the video of the challenge, which we'll show here after our break. And so they can see what their kids are doing, what they're working towards, and they get really excited about it. And then I get them involved. So I tell them, I would expect that every single one of you would be involved in some way. And so I recruit pit parents. So during the competition, and I'll go over that a little bit later, but during the competition, there would be a parent that would stay with them at all times. Now, this is because I had more teams. So I ended up with 10 teams and I couldn't be in 10 places at once. But a pit parent would just make sure that they're at their competitions on time, their different runs, and that they just someone to supervise them. And then this is also an opportunity to ask them, do you work for a company or do you know of a company that would be interested in sponsoring us? Because robotics is not cheap. And this year you have the grant, which is amazing. But to sustain your program, it takes money. And so if you are not in a district that supports that, or is not, does not have the money to support that, then this is a great opportunity to tap into what your parents are doing. And maybe they, because most companies, they want to be a part of this. And then I would always just put their logo on our shirts and maybe recognize them at competitions and things like that. So that's a great opportunity. And then I would explain the shirts to them and explain to them on how the pickup went and all of that. And then we actually had like different sponsor levels that we would ask of them. And then I would also have a chance to ask them if they would want to come in to our meetings and what kind of skills that they already have that could help us in our practices, whether it be in programming. I had a parent volunteer that was an expert programmer, and so he would come in and help us, things like that. And then I set up a remind, which I'm sure most of you guys are familiar with, a remind to keep them up to date on different things. So I'm not going to go over any of these other ones, but this is a sample sponsor request letter. So if you're just kind of cold calling or if you have a parent that says, yeah, my company might be interested, but I need a request letter. So you could copy this and adjust it to work for you, that you can use with sponsors in your area. Check out who's in your backyard, what kind of companies are around you that would think of this as helping to invest in their future employees. And then this is the team requirements, the student contract. So this is what, after they join the team, this is kind of what I have them, we go over together, and then they sign that. And then this is what the tryout requirements are. So this is what explains the video, and then it has the teacher recommendation form attached to it as well. So feel free to utilize those resources. Okay, I'm doing okay on time, a few more minutes. Okay, I just want to leave you guys with a couple of quick stories about some students that I worked with, and then we will take a break, and VRC people will switch over to a different room. Okay, so this one on the left, this team, these students right here, Jake and Chase specifically, they very set in their ways. Overachievers, you know, very much type A, want everything to be done a certain way, very strategic, not necessarily open to other ideas. And this, earlier when I was talking about like just watching these things develop over time, they absolutely will develop over time. And not something that you can really force. You just have to let the different situations come up and happen. And so this team of girls, they came up to them to strategize before a competition. And I watched them like initially kind of like be closed off to it. And then thankfully these girls were very persistent. Like, no, we need to discuss this. We need to figure out, we're ready to compete together. And you are our alliance. And so we need to talk together about how we want to score. And they had this clipboard that had the field laid out. And my team had never utilized these before. We had never seen them before. And so she started like laying it out, like, wait, so we'll do this, you'll do this. And I watched these students suddenly open up and really be open to conversation about it, where before they were very closed off and had their, like, this is how we compete, and this is how we drive. And I saw them adjust and make changes to what they were so used to doing, and it was so powerful. And I just stood back and took a picture because I just wanted to remember how powerful this moment was. And then you see Chase right here, he's really thinking hard about this. And they ended up doing very, very well together. And after this, they ended up making their own clipboard with their own paper. And I would see them then approaching teams from this point on about collaborating together, and just seeing that growth in them was really powerful. And seeing how they were way more open to collaboration after this experience. And then over here on the right, so we have these students. When we talk about some socially awkward students, that would be Drew right here in the red sweater. Very socially awkward. Don't know that, I think robotics was the best kind of place for him to thrive, but very much not really sure how to work with other students all the time. And then Sam here in the top hat, he very type A, very much straight A's, very much like a high level thinker. And Drew here dropped the robot during a competition at a very bad time. And they are sturdy, and a lot of times they will survive some falls, but this, it broke into a lot of pieces. And this is a situation where, and Drew started crying immediately. I mean, just sobbing, crying. And they could have all been really upset with Drew for dropping it. And I think initially there was a little bit of being upset, but then I saw these four boys pull together and be there to support him. And Dallas here he is being very encouraging, and he's assuring Drew it's going to be okay. We're going to fix it. We can do this together. And I, as the adult, jumped in thinking I've got to help them. Like they just dropped their robot. Like I have to be here to help them. And it didn't take long for me to realize, nope, I don't have to help them. They've got this. And so again, I stood back, took a picture instead, and just to remember this moment of seeing them kind of navigate through a very difficult situation, and bounce back and do just fine. So you have to be willing to step back and just let them navigate, let them figure it out. And you can see you can't really tell, there's a parent right here, and this parent is just watching, just observing, not saying anything, maybe an encouraging word here and there, but we just stood back and we let them figure it out, and they absolutely did. So I'll just leave you with that just encourage you that so thankful that you took this opportunity to become a robotics coach. And I believe with all my heart that you will not regret it, and that you will do an amazing job coaching these students. So we're going to switch. George, do you mind putting that link in the chat for VRC people? So if you are a high school coach, you're going to want to grab that link and go. It's a Google Meet room, so you'll want to switch over to Google Meet and then you'll just leave this meeting, and then that would just leave behind anyone who is coaching elementary and middle school. And then we'll take like a 5-minute break and come back and continue to the game reveal. So I'm going to switch to a timer so we can kind of see where we're at. And feel free to use the restroom, get drinks, whatever you need to do, stretch.
All right, Jamie, I'm going to head over to the VRC room and talk to them about the kits, and then I'll swing back over here. Slack me if you have any questions.
Sounds good. Thank you.
Jamie, are you still there by chance? I just realized that I'm recording on my computer, which might cause a problem.
How do we switch rooms again?
So if you're a high school, what you'll do is copy the link in the chat, and you'll want to go there. And then I don't think your computer will let you be on 2 meetings at the same time. At least your camera won't work. So you could probably click on it now, and then you'll want to sign off or close out the GoTo meeting. Jamie, I've got the recording, so
No, I think I'm recording because when I first started, it gave me like a notification, and so
okay.
I had to record. So I think we're good.
Okay, gotcha.
Yeah.
When I hit record, did you get a message that it was recording too?
I don't know what the message said, but it was very, it was like talking to me. So
Okay.
I just hit record to make it stop talking.
Okay, so you did it. Okay, it didn't show record on my end, and it was weird, so I just hit it record as well. So I'm gonna sign off. I'll see what happens. You make sure that yours is still recording on your end.
Okay, sounds good. forgot I was on mute. You think after a year and a half I would forget? I wouldn't forget that. We're gonna get started again, so hopefully you guys are getting back in and the cameras turned back on. Melissa, I saw that you asked for the link, and I put the link in the chat, but I took it from the URL as opposed to the share settings. So hopefully that will, you can open that up. If you can't, then you can grab it from our website on the Robot Resources page. And since we're a small group, don't hesitate to unmute yourself if you have a question, or you can still utilize the chat, but since we're a smaller group now, feel free to unmute if you want to chime in with a question. Before I get started, I just want to make sure, is everybody back? I don't want you to miss anything. Awesome, Rob is here, Michael's here. Yeah, if your camera is not on, if you can just let me know you're here, that would be great, because I don't want you to miss this. Hopefully you're getting excited. Awesome, hi Melissa. Okay, so we talked about before how the challenge changes every year. It's played on the same field. However, last year they expanded the size of that field. So it used to always be 4x8, but then last year they changed it into a 6x8. So since you guys are all new, for the most part, you shouldn't have to worry about that, because the field that you're getting through the grant will be the 6x8 field. However, if for some reason you already have 4x8 fields, they do sell an expansion kit. I think it's $100, and it gets you the pieces to be able to expand to the 6x8. If you think about this, is how long they had the 4x8. So I think the 6x8 is here to stay. I can't tell you for sure, but I think it's pretty much here to stay, and that you will not have to buy an expansion or a new field for a very long time. So the field that you're getting with the grant, it's coming to you. So Shannon, we are shipping it to you. So yeah, if you are a grant recipient, then we are shipping the field to you and the game elements. So, which is new for our grant, but I came on staff and I was adamant about, especially bouncing back from COVID, that I really wanted coaches to have everything that they needed to get started. So I can't tell you guys, well, this is a good year for you guys to be joining in, because you're getting a lot more than in the years past. And then moving forward, I don't know if we'll give the same amount. So this is a very good year to be getting the grant. So hopefully you have, so yeah, you're going to be getting all of this in the mail. Hopefully it won't take forever, but that is coming your way. And hopefully you have somewhere that you can keep it. I know when I first started out, we did not have a designated robotics room, and so we had to tear down and set up every single time we had a practice, and which was really annoying. But if that's all you have, it's all you have. It'd be nice if you had your own space like basketball does, or like some of the other sports do. But if you don't, we can make it work. I would take off the elements. It just depends, really, honestly. Like this, like last year, you could have just taken all of these off and it was just a flat field, and then you could have even like set it up and stored it in like behind something. It just kind of depends on what it involves. I have not assembled this field, so I don't know the extent of how much time that takes and if it's even realistic to take it off and back on. But eventually I ended up getting my own robotics room, which was a game changer because I didn't have to set up and tear down every time. But these do come apart into like 12 by 12 tiles. And so realistically, if you had to, you could break these apart and put them in totes and then store them, and then have the kids just help you put them back together. So that is kind of an idea of the field and storage for the field. Okay, we're gonna go ahead and watch this year's challenge. And so hopefully my sound will work and everything, but every year they put out a new video that explains the challenge, and it really does a great job of explaining the scoring. So I think this will be, oh, that's not it. There we go. Okay. Make sure you tell me if the sound is not good.
Welcome to the 2021-2022 game VEX IQ Challenge Pitching In. VEX IQ Challenge Pitching In is played on a 6-foot by 8-foot field. Robots and game objects start on the field in predetermined positions. Robots may cross freely from one side of the field to the other by fitting under the low bar. The scoring objects in VEX IQ Challenge Pitching In are balls with a diameter of just under 3 inches or 76 millimeters, and there are a total of 22 balls on the field. The object of the game is to score as many points as possible. Points can be scored in a few different ways. Each ball scored inside the low goal is worth 2 points. Robots can also launch balls into the high goal for 6 points. And teams can earn 2 additional 5-point bonuses by clearing the balls from each starting corral. But that's not all. At the end of the match, robots will race to climb the hanging bars in the center of the field. A robot that is completely off the ground will be considered low hanging and will receive 6 points. A robot that lifts itself completely above the low bar will be considered high hanging and will receive 10 points. Teams will have to experiment with different ways to keep their robot small enough to fit under the low bar, while also being able to score balls and climb. There are 3 ways to play VEX IQ Challenge Pitching In. First, 2 teams will collaborate in 60-second teamwork challenge matches, working together to maximize their score. Both teams will receive the same points. Each of these teams consists of 2 drivers and 1 robot. One driver will operate the robot for the first half of the match, and the other driver will operate it for the second half. Second, each team will have the opportunity to play driving skills challenge matches. In these matches, teams have 60 seconds of driver control time to score as many points as possible. Third, each team will also have the opportunity to play programming skills challenge matches in which they have 60 seconds of autonomous robot operation to score points. No drivers allowed. The scores for driving and programming skills challenges will be combined to determine the Robot Skills Challenge champion. Plus, all 3 gameplay styles have remote options for teams who want to compete from home. Check out the game manual or talk to your REC Foundation Regional Support Manager for all the details. For official game rules and robot requirements for VEX IQ Challenge Pitching In, please see the VEX IQ Challenge game manual found at roboticseducation.org and vexiq.com. To register a team, find events near you, or ask a question on the official Q&A, please visit robotevents.com. Good luck and have a great season.
Okay, so I will tell you my initial thoughts because let me back up here. So I was a coach for this season, so the last 5 seasons. And there's definitely some really cool elements on each of these, but seeing this one for this year, I am so excited. Like, in my opinion, it is the very best one we've had. And for at least as long as I have been coaching, I am more excited about this challenge than I've ever been about any of the other challenges. And since I can't actually coach, I get to help you guys get excited about it. Because it has so many different elements, and it has an end game. So when I say end game, I mean like the hanging at the very end. That you can't even imagine how exciting that is in a gymnasium or a stadium to wait and see like what they can do at the end is super exciting. So I think that you guys are going to really enjoy.
Welcome to the.
So let's break it down a little bit because that video can be a little bit overwhelming, and there's a lot of information in that video. So let's break it down just a little bit, and I can kind of explain to you how this works. And again, don't hesitate to throw a question in the chat or unmute yourself to get clarification. But basically, there's going to be these 3 ways to score, and then 2 possibilities at the end. So these are the 3 that are during the competition. They have this starting corral. I think this is what they call the starting corral on both sides. So if you can move these balls out of the starting corral, then that's 5 points. So they all have to be away. It's not 5 points per ball. It's if they're all out of that corral. So when we say if you can drive your robot, then you should be competing. If your students can drive that robot, then they can push these balls out of the corrals. So that's something to keep in mind. there are definitely so many different ways that students can be involved, even if they don't have this high level robot. So both sides have to be, so then this would also be 5 points. So possible 10 points to have both of these starting corrals cleared out. And then 2 points for each ball in the low goal. So the low goal would be on the touching the field. So inside of that center goal and touching the field would be considered 2 points. So if you think about it, if you're trying to throw balls in and they don't make it, then they could fall down and potentially still earn you 2 points. And then 6 points for each ball that's in the high goal. So you have that box at the top. It's has like plastic sheeting. The robot design this year has like a trebuchet component, so they can scoop up the ball and then they can launch it into that, into this high goal. So 6 points for every ball that is in there. Then for your end game, for your 2 possibilities at the end, is either a low hanging robot, so that would be 6 points. So as far as I know, yeah, there's a plastic sheet here, so I don't think you can hang on that one. So your options would be the one on this side of the field or the one on the opposite side of the field. So if you can get your robot to hang, which means it is off the field, so it's not touching the field, and they sometimes, if it's close, they'll do what they call a paper test, and they'll just slide a paper under there, and if they can slide the paper under, then it's considered a low hang. So it can be even just like the tiniest bit off of the field, and it still count as that 6 point low hang. And then the other option would be the 10 points for the high hanging, and that would be those higher posts that they would get their robot up there. And in order for it to be considered high hanging, it has to be above the bottom edge of the lower hanging bar. So if you see this visual right here, it's above that bar, so it's considered a high hang. So if they're anywhere below this bar, they would consider it a low hanging for 6 points. So that kind of lays out the scoring. And then our starting position, so this is a little bit different than the years past. They actually have an option to do a starting point on any of the highlighted sections. So they can choose to start their robot on any of these starting locations, the one team on this side and then the other team on the other side. And then in addition to that, the driver stations can change as well. So I think this is probably more of a COVID thing, that they're giving them the option to be further apart if they need to be. So they can either the drivers can be on each by the starting position, by the corrals, or they can be on the other side. So they have both options for that. I think it froze in the same spot as it did yesterday, George. The slides just froze. They have 1 minute to score as many points as possible with their alliance. I'm going to try to get this to advance. There we go. There we go. Okay, so this kind of makes it a little bit even more clear that these starting balls are scored when they're out of that starting corral. So they can be anywhere as long as they're not behind these black lines. And then if it's in the low goal, it can even be touching that border if it beats, as long as it's not touching the field out here, that would be considered 2 points. And this is another thing, if you have the most basic robot, you could already scoot all of those balls out of the starting position and start scooting them into the low goal. So still significant contributions you can make, even if you have the most basic robot. And this one shows an inside, and then also you can see, even if this gets really filled up and they start overflowing, it's still considered scoring as long as it's within the projection of that high goal. Some examples of not scored would be that these are still in the starting position, so nothing is scored there, and then this is outside of that low scoring zone, so that would not be scored. Are there any questions on scoring before I move on to a competition?
Jamie, there was just a question in the chat about, oh, I interrupted, sorry.
Oh no, I think I was reading the question at the same time.
Whit, did you have a?
So they're randomly, they are randomly with other teams. So it's a completely random selection. The computer selects it, and they usually have eight different matches and so that's 8 different alliances that they work with. So it's very random. And then they have more than 1 minute to discuss strategy. We'll talk about a sample schedule here in a second, but it just depends on the schedule. But generally, I'd say 20 to 30 minutes they usually have. That's also taking into consideration other things they're trying to get accomplished at the competition, and we'll actually just move on to that now, so that will help to understand. So they could have more time to discuss strategy before actually doing their run. Okay, so this kind of gives you a competition layout, so you can kind of get an idea of what to expect. Most schools do it in their gymnasium or cafeteria, or a combination of the two. And usually the pits, so that would be, in most cases, there's a table assigned to each team. So you sign up for the competition ahead of time, so they know you're coming. They will have it labeled, so you'll know exactly where to go and where to kind of put your things. There's usually bring lots of snacks. The parents like to bring snacks, the kids like to bring snacks. And then that's kind of like their home base, kind of like Indy 500, like where you charge your batteries and where you might modify a couple things and get ready for the next competition. So it's kind of like a home base. It would be 1 table per team. So if you end up adding more teams, then you would get additional tables as well. And there are generally at least 1 practice field in that area or somewhere in that area. So you don't have to worry about bringing your own field and practicing. They will have a practice field available. So in between their runs, they can practice with their alliance, or they even just practice on their own. When they get there, they'll have the robot inspected, and there is an inspection rubric that you can show them ahead of time. I always, from the very beginning, give them the rubric, so there's no surprises, and they don't have to worry about getting to the inspection and then realizing that their robot is too big, or it doesn't meet all the requirements. So there is a rubric that they would go over. They measure the robot to make sure that it's in the right sizes, and we'll go over the sizes here in a minute. But that kind of helps them. Then the competition knows that everyone has been approved. They're all legal robots, and then everyone's ready to compete. So once everyone has gotten inspected and everything, then that is when they formulate the schedule for the day, because they need to make sure they know exactly who's there first before the computer can generate the schedule. And then they will have a paper copy available for you, and then you can also see it on VEX Via. So there's a VEX Via app, which is super helpful because you can see the schedule and the scores. They will usually have monitors set up as well, so you can kind of see it on the monitors, but it's just handy to have it on your phone to see, kind of monitor that as throughout the day. And then you have skills also. We'll talk about that here in a second, but that's another opportunity for students to compete outside of their alliance. And then we have judges. So usually now at a competition, the judges will kind of walk around, but the judges will come and talk to your team about their robot. They'll ask them questions about the robot. They'll ask them questions about the design, their strategy, how they work together. So they can also earn trophies and awards based on their responses to those judges, and they can get trophies based on their design alone, or how innovative they are. Especially at the state level, we give out a lot more awards for things like that. Now, this year, things are going to be probably going to be a little bit different, depending on your school, depending on the schools that you go to. They may or may not have spectators if they're trying to control situations based on COVID. They may not have spectators, and they may just adjust or modify how they do their competition. So just keep that in mind. They might have scheduled times for you to come in and compete. As awful as COVID has been, it's also given us a lot more innovation as far as doing online tournaments. So you'll have opportunities where you can do it online. Now that you guys will have a field and the game elements, you will have the option, just with a webcam and a strong internet connection, you can compete from your home school. So that will be an option as well. And then let's see. Oh, don't be afraid to ask for help. As you can see in these pictures, it can be extremely overwhelming and a little chaotic, but do not be afraid to ask for help. I learned more during my time of coaching by asking other coaches at competitions than I ever did on my own. So It is extremely helpful to not be too prideful, just to say, okay, what are you doing and why are you doing it that way, or how is that working? It's very much a collaborative environment. Even though it's competitive, it is also extremely collaborative. I've never had a coach turn me down as far as a question, and usually it's so much so that they will come and show me themselves, or they will talk to my students for me. Like it's just such an amazing environment of learners and collaborators. You'll just be amazed at the kind of the way that other coaches are. And then, okay, so I mentioned that they will print out the match schedule. So this is an example of a match schedule that would print out once all the teams are checked in and inspected. So then this will show you what your schedule is. So you can, let's just pretend like you guys are like your team 2D. If that's your team, then I would usually just hand this to a student and say, okay, go through and highlight all of our matches. Everywhere you see our team number, go ahead and highlight. And your team number was in your registration. So when you registered, that was your team number. So you would highlight all of your matches, and there should be 8 of them. And you can also, like I said before, you can follow that schedule on the VEX VIA app, which is also super helpful. I would download that before any competition. And make sure that you're following the match number, so that the screen, the monitor will show you which match number they're on. So if they're on match 1, then obviously you want to get your kids queued up and in line because they're a match 3. And there's 3 fields, which means they're going up first. So they're going to fill up these 3 fields. And so you'll want to have them in the queuing line and ready to go. This will be a volunteer working the queuing line, and they're usually yelling like, "Where's team 222D?" You just don't want to be that team that's always late to the queuing line, or they're always looking for you. So you definitely want to watch that match number. They also have times, but I can tell you from experience, the time is not always in line with the actual schedule. So I would highly recommend going by the match number that you see on the screen as opposed to the time, because sometimes they're behind schedule, sometimes they're ahead of schedule. So I would definitely this is what the computer, like according to how long you have set that, according to how long it should take, this is what it shows. But then as things fall behind, it may not be accurate. So just follow the match number. And so you can see this is not super accurate to what you would have more time between each match, but you can see that you have more time here. So this would be way more spread out on an actual competition, but we made it smaller so you could see it on one screen. But you would just, this would give you an idea of how much time you have. So if they're close together, then you want to basically get right back in line to queue again. If you have more time, that would be time to go and talk to your alliance partner. So for example, for the next match, your team would be with 6471D. So you would go and find them in their pit area and say, can we practice together? What does your robot do? This is what our robot does. How can we score together? What can we do? So you can use that time to do that. You can also use that time to use the restroom and get snacks and take a break and all those kinds of things. So you do have time in between. Okay. And then there are 2 types of challenges. So we've just talked about the teamwork challenge, how it's 2 teams. They operate as an alliance to score points. So the misconception, a lot of times I had students from the very beginning that were like, oh, battle bots. It's not at all battle bots. It's actually the exact opposite. It's very collaborative. And so you want to work together on that field to score as many points as you can, as opposed to working against each other. So some of them are disappointed, but then it doesn't take long for them to realize that it is very fun, even when you're working together. And then you also have the skills challenge. So this would be, this is optional, where you have 3 attempts to do the skills challenge. This is driver controlled, no alliance. So this gives them an opportunity to show what they can do without an alliance partner. So this is what they've been practicing and at school. They don't have alliances when they're at school, so this is an opportunity for them to say, okay, this is what we can score by ourselves without an alliance. This does not necessarily, let me back up. Okay, so then programming is also, they get 3 attempts for programming, and that is autonomous. So they have programmed ahead of time. They have downloaded that onto their robot. It's just drag and drop blocks, which I'm sure a lot of you are probably familiar with. And then they can run autonomously, and they score points with that as well. So they have 3 attempts for each. neither of these are required at a competition. And at your first one, if you want to just focus on the teamwork and not necessarily move into this area just yet, that's perfectly fine. But I want you to understand, like when you're at a competition and you see a separate field with other things going on, that's exactly what is going on. It's the skills challenge. And this is a better kind of visual of the difference. So teamwork, these are two different teams. She's gonna pass the remote to her between 25 and 35 seconds, and then she will drive the rest of the time. And then the same thing here, he will pass the remote, and then the score that they get is both of their scores. So they share that score. And then, so that is your teamwork challenge. And then your skills challenge, as you can see here, neither of these boys have a remote in their hand because they are running an autonomous. This is one of their programming runs. And so they have pushed a button on the robot to initiate that program. And then they're standing back to see how many points they can score with that program. So that would be more of a skills challenge. Are there any questions about that before I move on? Yeah.
I have a question, sorry. So you said that the teamwork challenge is, we will for sure do that in the competition, but then the skills challenge, that's not mandatory?
Correct. Yeah. So,
okay.
So for the competition, the winners are the winners of the teamwork challenge. So it would be two winners. And then for the skills challenge, those scores help you like to qualify for the state level.
Okay.
So now there is an excellence award that you can't qualify for the excellence award unless you have done the skills, but let's just focus right now on the competition itself. But yeah, same field, same game, all of it's the same. It's just that you don't have that alliance partner. And yeah, we have what's called a global skills standing. And so after a competition, your team will end up on that list, and it will rank them in the state, in the country, in the world. And that score is what ranks them. And so in some cases, they can qualify for the state level without winning a competition based on that number.
Okay.
Does that make sense?
Yeah. And then to sign up, is that whenever you register for the event, do you choose if you want to do the skills challenge or not? Or when do you choose that you want to do that?
So that's a good question. When you sign up for the challenge, when you sign up for the competition, you show up. You don't have to tell them ahead of time if you're doing skills. You would just get in that line to do skills. So when you see that extra field that's not in front of the audience, that's what, and you see a line, you're like, what are they in line for? They're in line for skills, and it's completely optional, and they don't need to know ahead of time. When you walk up, they'll say, what is your team number? They'll pull it up, and then they'll enter your score, whatever you get on that. And so my first year, I don't think I ever did it. It scared me, it overwhelmed me. I was like, I'm going to stay away from that, focus on one thing at a time, which is perfectly fine. But if your students are asking for more, they're ready for more, there's no reason why they can't try it. It doesn't hurt them. You know, if they score 0 every time, it doesn't hurt them. It doesn't. Yeah. All I can do is help them. Yeah.
And then in the teamwork one, I'm sorry, I think you said this before, but so that's the actual like competition. And then the skills is just kind of like the extra that you can do to get more points and things like that. In the teamwork one, how many times did you say, like how many different teams will they be paired with in the one competition? 8?
8, yep.
Okay, so you'll do it 8 times. That's like a lot.
The first 4, after the first 4, they drop the lowest of the 4 scores. So it's really helpful as a coach when they have a really bad round, you can say, don't worry, they're going to drop that one. You're not going to, but then the next 4, they'll drop another one again. So they'll end up dropping to lowest, the lowest of the first 4 and the lowest of the second 4. So that kind of helps sometimes to encourage them. You can only say it twice, but
okay, awesome.
Yeah.
Oh, and then thank you.
Absolutely. And I like George said in the chat, we would highly recommend the skills. When you think about the skills challenge, the driving portion, we would highly recommend that because they're already qualified to do that. That's what they've been practicing. Now the programming side, the 3 attempts for programming, that's what we're saying. We recommend it, but don't stress yourself out over it. But the 3 driving attempts for skills, we highly recommend those because it can only help them. Okay. So here's a sample competition so you can kind of see what we're talking about on scoring. So if round 1, team 1 and 2 together, they score that 20 points, and 3 and 4, they score 5 points when they go. And then in round 2, Team 1 is now paired with Team 3, and they get 30 points. But now Team 2 is paired with Team 4, and together they score 10 points. So now you can see their total score. So they have some really good rounds, they have some really good alliances, and then they might have some that don't go as well. This is one of the things that I think makes robotics so interesting, is like you can't pick who you're with. You have no idea who your alliance is. And so prepping your students and teaching them, like, you can't always control the situations, and you can only do the very best that you can do, and teaching them how to be professional and be respectful is really important component at a competition. Here is a competition agenda. So when you go, generally on a Saturday, well, this would be on a Saturday. Now with live remote tournament, there can be some that can be after school in the evenings, but this is going to be the most common. This will be, so basically plan on like an 8 to 4 kind of day on a Saturday. And it's just one or, however many Saturdays you want to do a year over the season, but it's going to start with your inspection and some practice time, and then they're going to have opening ceremonies. They're going to have a meeting, which is you want to really listen in, especially your first one, because they're going to explain the entire competition. So, and a lot of them are taking into consideration that some of you are there for the very first time. And so they will be mindful of that for the most part. And so you'll want your kids to really listen in on that meeting, because it will help. And in some cases, they even take questions. I never did, because that could go on forever. But in some cases, they'll let the kids ask questions. And so that will kind of help. And then they usually break for lunch. It's usually a half hour to an hour, and then do more matches. And then they have the finals, and they give out awards. So that is a general competition agenda. Okay, we're making great time. George, have I missed anything? Because next up I have you talking about the world video.
Oh, I don't think so. No. I rearranged. I don't know. Go to the next slide, see what happens.
Oh, did you rearrange it?
I did, but that's okay. And it's probably because it doesn't go live when I rearrange it. No, that's fine. I can definitely talk about the world part. Yep.
Because I can come back to it. So I just realized I still have the kit to go over too. So.
No, that's fine. And we can do this now. This would be great. So I forgot. I only got to see a few of your hands, but remind me, how many of you actually been to a robot competition, seen a match in action? All right, we got one, which is great. That's awesome. And that was, I didn't see names. I think it's Bree. Bree, awesome. So what this video is I want to just kind of show you what a competition looks like. But I also want to make sure that you guys understand everything that Jamie's been prepping you and talking to you about is really about why robotics is important and why it matters to change our students and help our students. This is not about trophies. It's not about making it to state. It's not about making it to world. It's about robotics can transform and change the lives of students, whether they're low achieving, whether they're socially disconnected from other students or the classroom, where they don't interact at all in the classroom discussions or projects. This is great for those students. And it really, really emphasizes what we call those 21st century skills, which was that little diagram of problem solving, critically thinking, communication, collaboration. And a phrase that I like to say is it teaches kids how to be gracious professionals. And this video I'm about to show you is an exhibit perfectly of what Jamie and I and our TechPoint Foundation for Youth staff strives to do in the state of Indiana. So Jamie showed you there's 2,100 robotics teams in the state of Indiana. We send more teams to the state and world championship than any other state or country. I mean, Indiana really in the elementary and middle school space dominates with the number of teams. But we require that everyone goes through this training so that they really understand that it's not, here's your robot kit, go build a robot and hopefully you win. It is, I want you all to understand that robotics is really about those life skills that can be, that can apply to these students as they go into the real world. So I'm gonna prep this video and say that this is a grant recipient team from Napanee, Indiana. Is anyone from Napanee area up north? For those of you never been there, this is Amish Acres, where they have students who do not have running water, electricity, or internet in their homes. And they're on a robotics team that the students, their very first year on this team, made it to state and world. So this is the world stage. I'm going to prep one other thing. This is the finals of the world championship. So if they win this match, they win the entire world championship. There were 12 teams, I believe, that made it to the world championship. They were all from China, except for 2 teams from America. And they just so happened to both be from Napanee in the exact same school, a red team and a blue team. So the blue team you'll see here is paired up with a team from China. And I think we can probably play the video here. I might narrate a little bit here. So for those of you who've never seen a robot competition, this is exciting because you get to actually see like the energy and how fun these competitions are. We get to also see Jamie's ads. She hates mosquitoes.
Back to elementary school, the Hubble division, a team from Beijing and a team from Indiana on the Toyota field. Stephanie, tell us about these teams.
All right, thank you, Paul. I'm here on Toyota with the Hubble Division champion. They had a score of 40. Let's see if they can top it off. First up, we have 88299B. That's Science Museum 2 from Beijing, China. Their alliance partners are 15294B, Eaglebot Blue. They're from Napanee, Indiana. All right, are you guys ready? I said, please, ready? All right, let's kick things off in 3, 2, 1, go! All right.
So you can see the blue robot in the very bottom of your screen is the Napanee robot, and it's the 2 students on the right with the headbands. And then the team from China has the robot on the top right corner now going to the left side of your screen.
6 low scored hubs, 1 high scored hub.
You can see they have a strategy of clearing the field where the blue team is really kind of focusing on the bottom right goal, and the other team from China is focusing on the top right goal.
To the build zone.
But there's something that's going to happen here. And Jamie, if you wouldn't go ahead and hit pause. So this is a game from 2019, and the objective was to get those orange little hubs into the corners of the fields and stack them up high. And then there's one yellow hub at the very top. That's a bonus hub. And it was the strategy for at the end of the Chinese team to pick that up and stack that on their tower, but they're going to make a crucial mistake. Up to this point, everything's been perfect, but a crucial mistake's going to happen, and it's just going to domino. I'm ruining the drama here because you're going to see what's happened. There's a domino effect that is just going to compound and end in disaster. But there's one thing that happens, and I want you to pay close attention to what the girl does at the end of the match when she realizes her hopes to win the world championship is all over. So we'll hit play. Keep an eye on the girl driver.
The bonus hub is still on the structure. We'll have to see if they go back to get it later. 17 seconds left in this match.
Uh-oh.
The bonus hub has been knocked off of the structure. We have 10 seconds left. Let's see if they have enough time. Our pyramid gets knocked over. 6 seconds left in this match. It looks like our robots are going to go to hang. We have one connected. We have run out of time. My goodness, but that was fantastic.
And pause. All right. So, what did you guys notice that the girl driver did? You guys can unmute yourself. What'd the girl driver do? High five, is that what you said? Great, awesome. It was a high five. I call it the high five heard around the world because the team from China, they knocked over that yellow bonus, and then they chased it down and bumped the Napanee team, which toppled over their entire tower and creation. And at that point, there's no coming back from that, and you literally realize that your chances of winning are over. Had they done what was planned, they would have won the world championship. And I don't want to point at teams, but I'm going to, and I know this is recorded and it's be on YouTube. The Chinese team made a mistake, and it caused this alliance the world championship. And instead of being upset, throwing a little fit, being mad, throwing the remote down, running away, crying, and this is a middle school team. I forget what grade they're. Are they middle school or elementary, Jamie? Do you remember?
Fifth grade.
5th grade elementary team. As a 5th grade elementary girl, she reaches over and high fives the team, and just showing how gracious and professional a team from Indiana can be. So I show this video not to say, I want you all to be on the world championship final stage, or I want you guys to make it to worlds or state. I show this video to say, this is an example of what Jamie and I hope for all of your students, that even at their worst, lowest moments, they're very mature, they're professional, they're just that Hoosier hospitality we talk about is really contagious at Worlds, because we have more teams there representing the World Championship. There's more teams that, like I said, the World Championship from Indiana, and that's what I hope all of your students can do. So I wish you guys I only get to talk for a little bit of time, so I'm taking longer than I was probably allowed to. But I just wanted to just say in my closing comments of like, this is what we hope all of your students are able to do. Please don't strive for trophies. Please don't strive your first couple of years of try to be #1 or to be the best. That's not what this is about. All of your robots are gonna fall apart and break. That's okay. Your kids are gonna figure out how to put together. You're not going to do very well at your first or second or third competition. That's okay. That's not expected your first year. What's important is your kids get better along the way. They become better people, better versions of themselves, and they learn how to work together as a team. So I hope if you take away anything out of today is all of you can do this. This is one of the best things you can provide for your students. And this is not about winning. This is about collaborating, working together, and making sure kids become better problem solvers, collaborators, communicators. And I think this is the best way. Robotics is the best way to do that. So thank you all. Jamie, I kept myself muted the entire time until now. So thank you for letting me talk for a little bit. I'm going to mute myself now and go back to work.
No, perfect. Okay, so just as a quick reminder, it is a 1-minute match with 2 drivers that rotate the controller between the 25 and 35 second mark. So that's just a quick reminder. And then they can have 1 robot brain, and then they can have up to 6 motors on the robot. The size this year, it has to fit within, we had referenced before about the inspection, it has to fit within an 11 by 19 area. And it cannot expand beyond the 11 by 19 starting area at any time during the match. And it cannot be any taller than 15 inches in the starting position. Now, they can expand a little bit after they leave that starting position, but it cannot go beyond the 19 inches at any time during the match. And actually that bar, I think, if you think back about the competition, that the teal bar that was there, that's 19 inches. So that is a good visual for the students to know that they cannot build it any taller, or it can't expand any taller than that rod right there. And then you can also, this is also in the game manual, so I cannot stress enough referencing the game manual throughout the entire process. And then also utilizing that video that I talked about that kind of breaks down the game manual and goes page by page. It's very helpful, and I would even show it to your students as well, because it will help them. So we want you to think about signing up for a competition now, because they do fill up, and most teams do sign up for 2 to 4 competitions. So the best advice we can give you is to go to more than 1 competition. Like I said at the very beginning, the first one is probably going to be more stressful, and so it's kind of more of a dress rehearsal. So we really want you to go to a second one so that you can go in there with a lot more confidence and feel more comfortable, and it will be more fun for you after you've already kind of known what to expect. So there is a video link here on how to sign up for a competition. The competitions cost for IQ generally between $30 and $40 for a competition. So we are not covering that. We've covered everything else that you need to have a team, and so we are asking you to cover the cost of your competitions. I will say I charge my students, and if they couldn't pay it, it was fine, but it just helped. So I would charge them. When I first started, I charged $25 per student to cover, and I would say that this covers your t-shirt, it covers team registration, which you don't have to, we already covered that for you, and then 1 competition. then I put like a little disclaimer that would say like, if or when we go to other competitions, we may collect more money. Like if it, you know, and I would ask for like donations to help cover more competition in the event that we went to more. And then, but actually this last, I ended up upping it to 50 because things just got more expensive. And I actually added in there like to buy more equipment, to expand our program. And I had 100% of families return that money, because it's nice for them to have a bit of an investment. If they've invested a little bit, then they're going to be more likely to make sure that their kid is at practice every single week and committed to the program. So again, I didn't go chasing them for the money, but I didn't have any problem collecting it. But that's going to vary depending on your school and your district. So that's completely up to you. Okay, I think we're ready for the kit of parts, which I'm assuming nobody has, because I would be shocked if it shipped that fast. Does anybody have theirs? Probably not. Yeah, I don't think it shipped, but that's okay. I have one here I can show you. You'll see. Okay, so this is what it looks like. So it'll, when you get it, it will come in a box. You will have, I'm gonna have to stop sharing the screen. In the box is also this poster, and this is extremely helpful because as the students are working through that step-by-step manual of how to build that basic robot, it's going to say, go pick out a 2x4 beam, and it'll have a visual of it, but then for them to go through and find it can be challenging for them. And to keep them from constantly coming to you, like, I can't find a 2x4 beam, then I would always push my kids to go to this poster. They are in relation to the actual size, so they can actually take the piece and place it on top of the poster. So it's a pretty large poster. And they can put that piece right on top of that poster just to confirm it's the right size. So rather than counting all the holes, they can just lay it on there, and then they can look at it has the proper name for it, so they can compare to make sure they have the right piece. It really speeds up the process and makes it a lot easier for them if you can just point them to the poster. And every kit comes with it, so you'll have that ready to go. And you do want one kit per team. So if you decide to add more teams, you will have to purchase additional kits. You guys are the lucky ones because the VRC, the high school teams, they are suffering from a chip shortage. So they are not able to get their equipment like you guys are. So we're thankful that we can get our hands on all of this for you. But if you decide that you want to add another team, I would do it sooner than later, just to get make it less hectic for you and less stressful, and get all that going. And then once everything will be in bags, so you have to cut all the bags open, and they do come in bags that are organized based on the piece. So for example, like these are all of the gears, so you don't have to worry about separating them out. Like all the gears are in one bag, so you could just open up that bag and then pour them into your tray. So they all come with the tray. And then you could even print out this, so you could take this picture, print it out, and then when you laminate it. And so if you were really particular about how organized the kit is, and it helps a lot if it stays organized, then you could put this picture on the lid of the kit, and then that way the students know where to put things back and where things belong. So that is a little tip for you. As you get more teams, you might want to consider going to more of a communal equipment setup. So when you just have the one team, the one box works perfectly fine. But like for me, I ended up with 10 teams. And so once I had my own robotics room, it was a lot easier to set it up in a communal way. So it was like all of the gears together and all of the beams together and all the wheels together. And so when they needed something, rather than have the box, they would, and especially as you order more equipment, more pieces, then they can just go over and take what they need. And you can see like this one has the pieces on the outside of it. And so it can help you stay organized by putting all the right pieces back where they belong. Here's a link that, here's a video that George created several years ago that kind of walks through the entire kit. So we're gonna do like very basic level today, but you can always go back to this later if you forget something or if you need more information about something. This is George going over every single detail of the super kit. So you can always reference that link if you need to. So we're going to start with the controller. And like without you guys having kits in front of you, I'm just going to, am I big enough if I just show it like this, or would it be easier if I didn't share my screen? Is that okay? Okay. So this controller, a lot of the students are going to be very comfortable and familiar because it looks a lot like a video game controller. It has a lot of the same components. If you push the dials all the way up, that's going to be the very fastest. And then if all the way, or backwards all the way down. So all the way up is going to be the fastest. And you want to encourage them, like you want to go a little bit slower at first, take some time to get familiar with it. So the less you push up, the slower it's going to be. So the higher up you go, the faster it's going to be. So it has some different buttons that can be programmed. It has a power button right here on the front. It has this smart radio that is Bluetooth that's going to talk to the robot brain. And you want to really make sure like this is, you don't want this pulled out in any way. I think it's nearly impossible, but if you needed to take it out, you would want to unscrew the back where the battery is, and then there's a button to release it back there. So you don't want students yanking this radio out. I would generally just tell my students, like, if you need help with the radio, just let me do it or let a volunteer do it, just to prevent them from ruining that. And then the battery is stored on the back panel with that one screw. So that's pretty much the controller. And then the robot brain, which is between the brain and the controller are the most expensive components of your kit. So the brain, so here's the, make sure I can see. So here is the other radio. So those two radios are what talk to each other, the Bluetooth signals to make sure that the remote can drive the robot. And obviously the brain is where everything is stored. This is where you would download your program if you choose to do the programming route. To put the battery in, this is another thing. I have to teach my kids how to do this because I've had students put them in the wrong way and force it, and then they get stuck on there. So you want to make sure you stress to them that if you're forcing it, then it's probably not the correct way. It should go in very easily. So you can see that one side is just a smooth plastic. The other side has the metal pieces. So you want the metal pieces to go in first, and then it just slides right on there. And you'll kind of hear it click a little bit. So you'll want to tell students if it doesn't slide on easily, then you're doing it the wrong way. You want to make sure that it slides on easily. And then it just has this little pressure point that you can push and then push from the other side to take it off. And again, it doesn't come off easily, like you can't just take it off. So you want to make sure that they push down and then push from the opposite side. So it'll come off. And again, if they're forcing it, then they're going to break it. So you want to stress to not force it. Okay, so then you're going to turn it on by using this check mark on the screen. And as soon as you turn it on, then it loads. And like we said before, VEX they're the ones who make the product and sell the product, so that you'll see VEX on there. And then you'll see on the screen, I don't know how well you can see it, but there's it shows you the battery life. So my battery life is 100% right now. And then it also shows a radio signal. And it's kind of like your phone where it's searching for a signal. So it's moving. It's looking, trying to find a signal, and it's looking for my remote. So since my remote is not on, it's not finding it. So once I turn my remote on with the power button, you'll see the green light come on, and then that signal will become solid. So it knows, and is now connected with my remote. So that is solid. And then you can see both are flashing green because they are connected. Okay. If you have more than one kit, so if you decide to buy an additional kit, you'll want to, these come already ready to go together. So you'll want to maybe put a sticker or a label to say, like, this is brain one, this is controller one, so you know that these go together. There is, you can reprogram them, like you can recalibrate them, but it's just so much easier if you keep track of the brains that go with the controllers. So you might want to consider labeling those to know that they go together. And then I'm going to turn the power off by just holding down the X, because I want to add a couple of smart cables to this, so I can kind of demonstrate how this works. So I'm going to add 2 smart cables. Now these are like phone, old-fashioned phone cords. And students don't really know what these are because they don't have landlines. So a lot of times they've never seen these before, but they go in these ports along the sides. And so we're going to put them in ports 1 and 6. So 1 is going to control the left side of my robot, and 6 is going to control the right side of my robot. And when I put them in, they clip in very easily, so there should not be any confusion on how they go in. The issue is then kids want to just pull them out because they don't understand how they work. So you want to stress to them to make sure that they push down on that little plastic piece and then pull out. And some of you guys are young enough, you may not have ever seen these either. I'm a little older, so some of you guys might need to know how to use these. But yeah, you just click it in and then push down and pull out. And you're going to want to stress to them to make sure they push down before they pull it out. So I'm going to put 1 in the 1 port and then 1 in the 6 port. So then this is how my brain communicates with my motors. So this is a motor, and your kit comes with 4, I believe. Yeah, 4, I think. But you can use up to 6. So this is something that if you have extra money, you might want to consider buying more of them. They do burn out over time, so it's nice to have extras on hand. And then sometimes students do want to use more than what the kit has. So that is something that you might want to buy. And I think they're about $20 a piece. I think that's about right. Okay, so I turned my brain off. So you don't have to turn it off, but I think it just helps to have it turned off before you put any new motors in. So I'm going to connect one motor to that one. And then I'm going to connect another motor over here. And then I'm going to turn on my brain and my remote. And you can actually, if you turn on your remote, it will turn on your brain, so they do kind of talk to each other. And then I need to enter driving mode. So just by turning it on does not necessarily allow you to start driving right away. You'll see it says program, says driver control and demos. So I want driver control, so I'm going to do check mark and then run. I'm going to do check mark again. And then it's a, I know you can't see it, unfortunately, but it says running. And it starts a timer, so it shows me that it is running and that I do now have the capability to drive with my remote. Now, since I just have my motor, I don't know if you can see this or hear it, but so I'm pushing up on the remote, which is causing my motor to move. So you can, I don't know if you can hear it rotating, but that is causing that to rotate. And then if I do my other toggle, then now this one is moving. So I can add an axle. So there's this is an extension of the motor. So I can add the axle here, and then I can put a tire on there. Just to kind of show, need an assistant. Okay. So then once I have that, then when I push the remote, then it rotates the tire. So the tires are not going to move if the axle is not in this drive shaft. And so it's really important, and you will like have so many students that will say like, it's not working, it's not working. 9 times out of 10, the issue is that this axle has come out of this hole that's on the motor. And it's not a very deep hole, so it comes out very easily. And so if they have not, made sure that stays in there, then that's the most common mistake. So you'll want to ask questions like, are you sure that axle is all the way in? So your students will think you're amazing when you when you know what the issue is with the robot not running. So that's the most common issue, would be that coming out. Any questions about any of that? I know it's difficult with you guys not having your kids. Okay. Let me turn that off. And then to turn it off, you just hold down on the X. And that will turn it off. So let me just go over a couple things. Since you couldn't see it very well, this might help. The check mark is to turn it on, but it's also your enter key. So if you need to select something, you'll also use that check mark. And then your X would be to go back or to turn it off entirely. And then once you turn it on to enter driver control, you're going to select driver control and then run. And then you'll see that running screen that has the timer on it. Here's a better picture of what the radios look like. So this is how the robot brain and the robot controller connect with one another. So this is how they communicate with the Bluetooth. These are your batteries. So the robot battery is the one that I showed you that goes on the brain. Then the remote control battery is the one that you don't see it because it's inside of your remote. This is what you have to unscrew to get to. These will last for a very long time. So there's really no reason for you to take that battery out. I've only had, in 5 years, I think I've had to replace 1 or 2, but very, very uncommon to replace that. It lasts for a very long time. So no need to necessarily take that out, but that is what it looks like on the inside of your controller. And then this is your USB to micro cord. So this is what you're going to use. That will connect to your controller here. You can use that to charge your controller. So you'll see a red light will start appearing when the battery is running low on this. Again, it doesn't happen very often, but you want to charge it using this cord. And then this also connects to your to the charge adapter. And then this is what we use for programming as well. So they would actually connect it to. So if they're programming, they would connect it to your brain right here, and then the USB into the computer, and that's how they would transfer their program over to their brain. And then this is also for firmware updates. So occasionally you'll turn your brain on. It shouldn't happen very often with it being brand new, but you'll see it'll say update needed. You'll just plug that into your computer, and then it'll pop up with the commands on how to update your brain. So like a computer, you still have to update it from time to time. So just to review, for charging, your controller can be charged on your computer as long as your computer is on, or into the wall if you have a outlet cube there. And then your kit will come with the cord to charge your brain battery. Or I'm sorry, yeah, your brain battery. And your brain battery is best if you charge it, keep it charged. So unlike the controller, this has to be recharged pretty often. So I would just get in the routine of when it comes time to clean up practice, I would always tell my students, make sure all your batteries come out of your robots and put on the chargers, just to ensure that at the next practice we would have charged batteries. So those tend to drain a little bit faster. At competitions, you probably make it last through a competition, but you're better off charging it in between runs to make sure they have a full battery. Okay, these are your smart cables. This is what we talked about. They look at the phone cables. They have all different lengths. So sometimes you need it to like wrap around your entire robot. Sometimes you need shorter ones, so you can utilize different lengths of them. This is up close of the motor, and this is with the speed, the direction, the time, and the revolutions in degrees. So this is what you need to basically have any kind of motion or movement. You have to have a motor for it. And then here are the beams. So we have the we call them 1 by, 2 by, and 4 by. This is 1 by, and then however many holes, or sections, I should say. So like this tiny one is a 1 by 3. This is a 1 by 4. So that's an easy way to identify them. These are, this is like a 2 by 2, 2 by 4. They generally go in, most of them go by even numbers. You can order additional pieces that can be kind of odd lengths. So those will in the odd numbers, but most of them go by even numbers. And then the 4 by beams as well. And then we have the pin connector. So this is what connects them together. So there's 3 different sizes of pins. There's the 1 by 1, the 1 by 2, and the 2 by 2. So they're just the different lengths. And when you put them in, you just simply snap them in with this, and this will help you. This makes it a much stronger connection than what like maybe a Lego would be. And then that you can attach any other beam to that. Now to get them out, sometimes they can be really hard to kind of pull out. And so a trick to that would be the the flat side where the line is, if you go perpendicular and take your nail and push perpendicular to that, and then it kind of releases it, and then you can pull it right out. So it makes it a lot easier. A lot of students will try to use their teeth, and I can't stress enough to urge them to not use their teeth. Teach them this trick instead, so that they don't feel like they have to use their teeth, because you know that's obviously gross and will destroy your equipment. Another option would be to take another piece and push it through, much like what your finger would do or your fingernail, perpendicular to that line, and then it will come right out. So that's a little tip that I think will extend the life of your pieces. These are the corner beams. Some of them look very, very similar. So I would stress to students to, when they're following the directions, to look at them very, very closely to make sure that they have the right one, because this is the kind of piece that if they put the wrong one in, and then steps later, something's not working properly, it might be because they put in the wrong size. So you kind of have to revisit the step that they've already done to see to make sure they use the right piece. And some of them will say, oh, I couldn't find that, so I just use that one instead. And that's not going to be effective. So you need to make sure they have the exact piece that they're looking for. These are the standoffs. So where the blue connector pins allow it to kind of pivot and move around, these are going to be more stationary. So when you're trying to connect two pieces and you don't want pieces to move, they would use these stationary pieces. These are the shafts and axles. There's metal ones and plastic ones. On the wheels, the metal ones are a lot more effective, and they're obviously sturdier. They last a lot longer. These are very hard to tell in the picture, but they look a little bit different. So you want to be very mindful of that. And again, with your students, be very careful with that. Some of them have like little stoppers on the ends of them. And so you'll just want to make sure that they notice that and that they get the right pieces, because these over here do not have stoppers. And then these here have stoppers just a little bit of a ways down. So being all black, they can be hard to tell the difference. So just make sure that you are mindful of that. These are the gears. You will not need these two crown gears in the middle, so you can set those aside when you get them. Those are not necessary right now, so I wouldn't worry too much about those. Also, the pulley pack that comes, I would not introduce that to your students at this time. I would not worry about that so much. But a lot of the Project Lead the Way classes use these, so they are included, but I would not necessarily use them right now. And then we have all of these different sensors. This we would usually say you won't use these in your first year. But however, this challenge this year and the robot that they put out this year does incorporate a bumper switch. So this does come in the kit, and you will utilize this for the suggested robot build. Touch LED, this outputs colors and inputs touch. So it's like if they want to initiate their program by pushing this instead of on their brain, they could utilize it for that. But I'm just going to breeze through these since you're not going to be using them this year. Ultrasonic sensor uses sound waves to measure distance. The gyro measures turn rate and calculates direction. You have your infrared sensor that detects colors of objects. So there was a game a while back that had different color rings, and so it could like sense the different colors and get certain colors to be able to complete the challenge. You'll see some of the more advanced teams might use things like that. This is the blue Ethernet cable. So this is what you would use if for some reason the robot is not communicating with the controller and vice versa. Then you would utilize this. They can drive it attached to this cord. That makes it more challenging. But if they had to, they could drive it with being attached to this Ethernet cable. It's a very long cable. You can also use it to recalibrate. So that way you can connect your control. If your controller and your brain aren't talking to each other anymore, you can use this to calibrate, and all the steps for that are on your brain. Just a quick reminder on the controller, it comes pre-programmed for joystick mode, and that's the most common. So by default, your remote is set up for joystick mode. It is a driver preference. I'd highly recommend just keeping it the way it is for this first year. But if you have a more advanced driver or more advanced student, they might want to consider changing and programming their remote to do something a little bit different and work a little bit differently. They can change it to where just one joystick controls everything. So that is something to consider. We're almost done, guys. We're going to be on. Might even finish early. Okay, this is a list of YouTube resources. So this kind of all the things I've just shown you. This you can go into a lot more. Oops, sorry. You can go into a lot more detail with some of these links. So this is here for you as well. If you want more information about any of the different pieces that I've shown you so far, you can go here to get more of an explanation and a demonstration. In your box, you will have these books that come with your kit, and this one is for the most basic claw bot. This is like kind of the most basic of all the bots. I would hide this from your kids. You don't want your kids to build this one right now. I wouldn't say throw it away. I would just say put it aside. You never know when you might need it, but it has just like the online. This is the only like printed one as far as booklet. But you'll want to put this aside and not let them see it right now, because this is not going to necessarily be the right fit for them for this challenge. You want to encourage them to build this year's challenge robot, which is called Fling. And then it also comes with this control system user guide. So it really does a good job of kind of explaining different components, and you can always reference this if you need help. It shows you how the batteries go in, all of that, all the things I just showed you, and that can be found in your kit when it comes. Here are where you can find different things in the booklet. So this is probably the most common things you might be interested in. And then here are the robots that I referenced. So your Clawbot IQ is your most basic robot. These have all been created based on different challenges. You're not going to be able to get much accomplished with the VREX, but it's obviously something fun to build. And then this year is Fling. So this is the one that they're recommending for this year. And you can see it's just step-by-step on how to build. And I'll tell you ahead of time all the pieces that you need. So some students, they prefer to pool all of their pieces first, get them all prepped before they start building. So if that's what they prefer, then they have that option. There's that bumper switch I was talking about. You can see that you just have that one motor, there's 4 motors, 2 of each of these, and then 1 of that size, and it shows the sizes right here, and then you can compare that to your poster that shows all the different equipment. You see all the pieces that you'll need, and then again, it will just take you step by step, and you can see those are some of those corner beams. You want to be very careful that you get the right ones, and then you have these very tiny little rings so that you'll want to make sure those don't get lost as well. So kind of some things you might have to train your kids on from the very beginning as far as keeping track of equipment. And then you can have students, you could print this for them if you want to, or if they have devices, they could pull it up on you can just type in VEX IQ robot build, and then that way, if they have it on their own screen, they could zoom in if they need to. So if they need to see it a little bit bigger, then they could zoom into it. So if you have devices that they could use, the paper, some kids prefer paper, so you could just print them out, but there are a lot of pages to this, and you would want them in color because that way you could decipher the difference between the pieces. But the other option would be an iPad or a computer where they could pull it up, and then that way they can zoom in and see it a little bit better. All right. Okay, so we talked earlier about not rebuilding. So this is what we mean by not completely rebuilding. This would be considered your drive base. We know that students are going to make modifications. We encourage you to have them make modifications, but if they're going to make changes, do not let them rebuild down past this right here. So pretty much every single robot has a very similar drive base, and so we want them, once they have this built, then they could really prototype and modify anything they really want to for their robot, but really encourage them to not go any less than this right here, this drive base. And then this is Fling, so this is this year's recommended robot. So it's going to have an intake of those yellow, almost like khaki sack balls, and then here's your stopper, and then this is kind of like a catapult, like a trebuchet, where it will come down, take one of those, and then you could fling it into that scoring zone. So that is that. Okay. There's a lot of talking. So I just want to wrap up by saying thank you so much. We truly appreciate your willingness to give up 3 hours of your summer and to sit through and listen to all of this content and information. And we are here to support you. Please be flexible and open-minded. It's okay to be a little bit, apprehensive or a little bit scared. We are here to support you and be with you throughout the entire process. And do not hesitate to reach out with any questions or concerns. Are there any other questions or concerns that I can help you with right now? We did finish about 12 minutes early, so wonder if we beat VRC.
All right, let's give Jamie a round of applause for her first robot training. Yay! And you finished on time. All right, I don't see any questions in the chat. You did it.
I'll take this time to just say, if you ever need or want, depending on how far away you are, I'd love to come by and see, help you out, come see your setup, and whatever I can do to help you. I can be on site at times as well, depending on what COVID restrictions are in effect and things like that. But don't hesitate to reach out if there's anything I can do to help you on site as well. Okay. Easy. I hope all the groups are this easy. That's a great way to start out. All right, you guys. Well, I hope you have a very restful summer, and hopefully you can enjoy more summer and not have to get back to the classroom so soon. And please don't hesitate to reach out if you need anything at all. Okay.
Thanks, everyone. Enjoy the rest of your summer. Hey, Jamie, nice job.
Thanks.
On the recording, I think there's going to be 2 options. It's either going to be an online or a save, so you can